So we want to welcome you all to the virtual PD for solar eclipse, brought to you by Purdue University, K-12 Science, K-12 Outreach,
Yeah.
Superheroes of Science.
All of these things.
We're very excited to be able to present to you a whole bunch of different activities. For your knowledge, a couple things. If you see us looking like past the camera, like up, we have you guys up on a big flat screen TV on the wall, so we're looking at you on that as well. So if you kind of, no one's behind us to look at you, we're just us.
They would know. They could see behind us.
Oh yeah, okay.
You're telling them things they know.
So we're very excited to be able to do this. We're going to do some quick introductions on our end so that you guys kind of know who we are, and then we'll get started. Sound like a plan?
Yes.
Yes. Did you introduce yourself?
I'm not. Sarah, would you like to introduce yourself?
Sure. Hi, my name is Sarah Nern. I am the K-12 Outreach Coordinator for the Department of Chemistry here at Purdue University. Prior to here at Purdue, this is my 6th year at Purdue. Prior to that, I was a middle school, high school mathematics and science teacher in Western Indiana, West Central Indiana.
My name is Stephen Smith. I am the K-12 Outreach Coordinator for the Department of Earth, Atmospheric, and Planetary Sciences here at Purdue University. I've been here for a while. And prior to that, my background was LA.
Awesome. My name is Bill Bailey, and I'm the director for the outreach, director of outreach for the College of Science. Before this, 20 years ago, I taught middle school and high school science for quite a few years, and been here and enjoying helping teachers teach science better any way we can. Cool.
Great.
Sure. I think they cared.
I think they cared a little bit.
You think they cared?
So,
Okay.
all
Is
right.
that like all for like validity? Is that why we do that?
That's why we do it.
We always do that.
Sets the stage.
So I do think it's cool. So Purdue University, because it's a land grant institution, we have to, one of the giving back to the community is part of that land grant mission. And so we are giving back to teachers all over the world now at this point. And we're pretty excited to be able to put together professional development opportunities for science teachers. But our focus over the last couple of years in the summer has been to do the middle school professional development. We have
Someone has no audio. Can you guys hear us, or is he just like a talking head? Oh, we got thumbs up. Hey, Andy's here.
Hi, Andy.
Yeah.
Okay.
So answer. You want to do that?
Yeah.
Say it's not us, it's you.
So we're going to go through a tremendous number of activities during this. We will give you access to we'll show you where the websites are with links to all these activities as well. And that way you have them for now until eternity. It looks like we didn't know how many people were going to show up. If this is the number of people, that we might open it up and let you guys ask questions verbally versus doing it via the chat line. But if you have a question and you just want to type it in the chat, go ahead, do that. I'll watch the chat and see if there's anything that we need to stop and do. But we're going to go through a good number of lessons in 3 hours. And all these lessons, we have links and videos and all kinds of stuff online for them already. Make sense?
Yeah.
Okay. Who wants to start?
Can you hear me now? Yes. Okay. All right. So let's just start with.
Depending on where we start, let's be sure and share the link through the chat.
Okay, I can do that.
Well, I was going to put it up here.
You go ahead and do that and I'll
Would you
share
like
the link.
to manage me the entire 3 hours?
Are you going to start with the middle school one?
Yes.
Okay, go ahead.
Tell you what. People. All right, here. Can you guys see whatever that random thing is? Purdue Superior Science. Do that. Then look at there. Purdue Science K-12. That's how I always get places.
I shared the link for the,
Teachers, did you share this link?
Yep.
This is the link. Hey, you guys see the pretty picture? I mean, come on, Andy, give me some kudos. I made that. I got a head shake. I'll take it. All right. So information about the eclipse. If you need background information and you don't know how to Google, then you can read this page and it's all right there. And all the good information about eclipses. But what really cool stuff we're going to play with today are we're going to go through these two links. And don't bell out if you're middle school when we get to the elementary, because some of the lessons that we designed for the elementary are good for middle or high school, to be honest. Some of them are actually lessons we've done with high schools, and some of our teachers teach for other programs. But we've just altered them a little bit so they worked also for our elementary teachers. And so we're going to start here with the middle school classroom one. And we taught this workshop in-person workshops was it last week?
It was 2 weeks ago.
2 weeks ago? Okay. 2 weeks ago, we did in-person workshops. We did a 2-day for middle school and a 2-day for elementary. And so rather than making like a brand new page, another page for people to find, we thought it'd be best just to kind of go through, and we're going to go through each of these lessons and kind of explain them. Fair enough?
Yes.
Yep. All right, you're up for my NASA data.
Perfect. All right. So we had a representative from My NASA Data here helping us at the in-person. They shared some links with us, and we'll be referring back to the My NASA Data educational resources throughout today. But we kind of set the stage with just the purpose why we're observing a solar eclipse. And My NASA Data, just kind of like how the name sounds, it's a NASA-sponsored program that takes data collected in various ways, and they go in and they make educational materials about it. And so this first link that we see, this observing the sun during a total solar eclipse, what we see here is this you can print on prints large onto a large sheet of paper, but it's an interactive. It takes students kind of looking at the different pieces of a solar eclipse, and they have a slide deck that they include in this, which I'll put in here. For all of their materials, they are going to force a copy into your Google Drive. So this is a normal, if you've not ever seen this, this is a normal kind of warning screen here. Just basically it says we're putting a copy of this right into your Google Drive for you. And here they've just, what's nice about the slide decks that they have, it's a lot of really nice, it's vetted material. It takes a long time to approve something like this through the NASA program. So you know that the material here has been used in classrooms, it's been used with teachers, and it goes through a really pretty lengthy approval process. We were excited to showcase it, like we said, 2 weeks ago at our in-person PD. But you see again, another picture of this, what is a solar eclipse tutorial here, a video. And as we go through, we have a couple of interactive slides. So this first one, it says, arrange the images to show how the 3 celestial bodies might show up in a solar eclipse. And you can go on. We know that if the sun's here, we're going to move the sun, we're going to move the moon so that it's between the Earth and the sun. And this is the arrangement we might expect to happen during a solar eclipse. Continuing on, talk about a partial solar eclipse. For this one, it says label each image as a total or a partial solar eclipse, just based on looking at the different images. This they were talking about, there's a lot of references made back to the 2017 eclipse event that happened. And then, of course, leading up to, even though we have an annular eclipse coming this October, a lot of the plans are also making reference to the total eclipse that will be happening next April. So that's kind of it for this first slide deck. And then looking back is kind of an introduction to it. Of course, reminders about not looking directly at the sun without proper safety equipment. And then, if you're interested in receiving an answer key, some of these slide decks have some different activities and that students can do, like manipulatives and things,
It's like the one you just did with the moving the moon thing.
or
If you
labeling.
don't know the order, then,
You can put in a request for a teacher key and they will get back to you. They kind of do what we do. They verify that you're actually a teacher at that school that you're requesting it from, not the student. They're really careful about making sure that students aren't getting access to those answers, and then they'll send it straight to you. And then they have linked a lot of these to the next generation science standards. All right, and then you'll see a variety of complementary lessons that come with the MyNASA data. So that's just a little background on the MyNASA data. They also have, or is this getting into, no, that's not. Another link, calculating the ratios of an eclipse. And again, they have a spreadsheet located here, and it's an activity that you would share with students. Again, it's going to prompt you to make a copy directly into your Google Drive. And you're going to notice at the bottom, they have the introduction and then each of the activities as we go through them. And again, they're going to have, if you're interested in receiving the answer key, you can make that request there for it. But they're going to go through how to work through that spreadsheet.
I would change spreadsheet. When you make a copy, I'd change it because, I mean, it pretty much gives you the answer
Yeah,
stuff. So if you want to either do that as a class or change it if you're going to assign it.
yeah, you can
I
go
like
through.
the way it gives you the answer.
Yeah, here, I think, this very first one's a good example. You could as we were going through this with our middle school group, we all sort of agreed, yeah, we would probably remove this first before we shared it with students, and then each of them. But I think they scaffold it in a way that, some people might want to see the answer if they're going through, but definitely, I agree. I think I would remove it first before sharing it.
Well, if you agree with me, then you're not wrong.
Okay.
Not today.
You got to close some of the tabs. You can't
Okay.
have 400 tabs open. My lands,
Right.
this is terrible.
Okay. So that's kind of a quick discussion there through some of the MyNASA data resources, but we'll refer back to MyNASA data quite a bit. But that's just kind of an opening, a couple of activities to get us started thinking about what a solar eclipse might mean.
Bill, you want to talk about gravity universe model?
Sure. I want to make sure that the people that just came in, I'm going to reshare. This link is kind of where we're going down through each on this website, and all the links coming off of that go to each of the activities. So we have that. Okay, and if you have questions, at this point, we're still not an extremely large group. If you want to unmute yourself and ask, feel free to, or if you want to type something into the chat, you can do that as well. Okay, I'll talk about the gravity universe model. So if you've seen these before, they're basically they're basically a hoop, and then after the hoop, you put on some fabric, and it allows you to do this. So I'm going to show you, because I think these are ones that if you don't have one, you can make your own, and we found a real easy way to make these. So this tube is water line tube. So it's actually what they use now to run water in houses. Okay. And you can get this at just about any store, and they're not any like Menards or something like that. I don't know, depending on where you guys are, what store you have, a hardware store. And then there's these quick connects, and I'm going to try to get this kind of close. So these quick connects are awesome, and they sell them right with that same tubing, so that you can then push these in and it connects, and they can't come apart unless there's a little black thing on here that you push back in, and then you can pull it back out. So that nice thing is then you can store these fairly, they can make these pretty tight to store, as opposed to leaving a big hoop if you don't have a place to store it. The great thing is that's your hoop, okay? And then all you need is, and you can go online, there's a bazillion of these. We found all kinds of, it's just a checkered fabric, okay? And it is a spandex fabric. So it's got some give to it. Thank you, Andy, for laughing. Okay. good spandex fabric. So then what we're gonna do, and I'm gonna do this over here and then I'll move back over. We're gonna put clamps.
I don't know why Bill bought extra spandex fabric when we ordered this.
So these are cheap. I will. These are cheap little clamps. Okay. I got boxes of these, big box, and then you probably don't, depending on how you're going to do this, you can do it where each group has a set of these, or you can decide to do it different. I don't know how you're going to do it. But then these clamps just go on. They just literally just clamp on nice and easy. We found that about 8 clamps to one ring is the best because it allows for some flexibility of these. So then you just keep going around, just clamp them on. And then once you get them all clamped, then you can clamp more as you go. That's all right. Now, I'll give you my 2 cents. When we did this the first time doing this, I felt like it needed to be real tight. Having it real tight doesn't help you as much. Getting it just about to a point where it's kind of straight across, about like that. You don't need to like try to pull it real tight to make it go completely tight. That's not the point, and you'll see why in a minute. So everybody see what we just did there? We just took that fabric and just clamped it around that ring. And that's it. So it sits just like that. How you put these on things, like you could put books on 3 of the sides, or if you have desks or lab stools or whatever you want. You just want it where the center part is able just to sit. Okay, so what they do is they talk about, yeah, I don't know how well this is going to come across. So the first one I have is just a wooden ball, okay? And we'll see if I can see how you guys can see it from here. But we can roll this across and it just goes straight across, okay? Really nothing to it, just goes straight across and went straight off the edge.
Catch.
Okay.
Wheels from.
So now if we add, I'm just start with a smaller one, steel, and you can get steel balls, different sizes. There's a larger one. They are expensive, but once again, you're going to buy them one time and then you're going to have these for quite a while. So then what we can do is I'm going to put this one down in here. And when it did that, it dropped this down in. So now we have the center of this being pulled down. So now if I go to roll, I'll start with a marble. Now if I go to roll a marble, and I'm going to try to roll it straight across, let me try it again.
Yeah.
If I try to go straight across, see it, as it started to get close to it, it was pulled by that center marble, the center steel ball. I don't know, are you guys able to see that? Someone shake their head if you saw it. Okay, good. So I'm just trying to roll it, and it immediately starts to curve as soon as it gets in there, because it's the gravity's pulling that towards that larger steel ball. If I use a really large steel ball, one, you're going to see that it quickly pulls that fabric down in more. But now if I start to roll this thing just completely starts to get pulled. Now, this is where you want to let the kids play with it. You want to let them look at, okay, so that was the one. What if I roll this bigger steel ball towards that one? Does it curve as much? What happens? There was also some activities you could do with this where you could put, like, if you had 2 of these steel balls, you could put one on one end and one on the other and see what happens when it does that. It's a nonstop, basically a chance for them to play with what happens when we have gravitational pull among 2 objects. And that's really what you're looking at with this, is the gravitational pull in space among 2 objects. And we always say that, you know, if the 3 of us were out in space, you know, I think I weigh more than Steve, I think. So I probably have the largest mass. Ideally, they would both be pulled towards me, and this is kind of showing that. Go ahead.
What's the significance of the checkered? Do you have to use the checkered fabric, or what if we just use spandex?
It's easier to see. The reason we went I would say David had done this before and used the checkered fabric. When I did it with Austin and physics, we didn't have checkered fabric, but the checkered fabric's nice that you can track if you're rolling it straight across, you can track it easier, and you can see you can see the perceived change. And so it's discussing thing about Einstein's theory of relativity and space-time warp. And so you could kind of perceptually see that with the checkers. I really liked it when he mentioned checkered fabric. I had not thought of it using checkered fabric when he did that, and so I really liked that he did. But Bill, don't forget, just because you would have more mass, we would also pull on you.
Right.
The pull is not as strong.
It's not as strong.
Everything with mass has gravity, and you can see this. Even if you use like a really large object with mass, and when we did physics, I think we used like just a weight. We just stuck a weight. It wasn't a round ball. We just stuck a weight in the middle, so you don't have to spend a fortune to buy the really big steel ball bearings. But when we used those, and I forgot what I was talking about.
I think just any, if it has mass.
Oh yeah. And just to show, and that's how, I mean, if we look it up, that's how we learned about gravity and stuff. And that's how we know about some solar systems, what's going on, because the bending, some stars are large enough, they'll actually bend light. So part of the electromagnetic spectrum will actually bend and warp around. That's how we know about a lot of things in space, which I don't remember what it all is off the top of my head.
So the one thing that, the kids will see on this is, after a while that marble or whatever you're rolling around, the bigger object starts to eventually spiral towards the center. And the kids will ask, well, then how come we haven't spiraled towards the sun already?
We're working on it.
Okay. Well, we're moving closer, but but this has friction on this where we don't have hardly any friction out in space. And so what we have is it's not being pulled as fast, but it is being pulled. It is being pulled closer and closer.
And someone mentioned they might whip stitch the fabric to the hoop. We just, we send this out to some local teachers and stuff. And so we wanted to make kits that we could fold down and not take up much space at all. And so that's why we went with this setup rather than actually doing it, stitching it to it or something like that.
There's also,
is there a minimum size hoops that works? Have multiple hoops for, now you and David played with different size. I don't know I know the one in physics is like over 6 feet in diameter.
Oh, wow.
I don't think the size of the hoop, but then once you start to add in, if you've got and if the three of us are lab partners and we're all looking at this, it needs to be big enough that we're able to all to be kind of around it. You could do smaller than this, but then the masses and how many times it'll rotate and all that, I think that will change. This is probably what, 2.5, 3 foot across, somewhere around that. That's the distance, but it's not a like a have to have exactly
Parachute.
Marcy, I agree with you. Having one big one would be awesome if you can do it in your classroom but that's once again space that it takes.
And they use PVC to make theirs.
Yeah.
Like I said, because PVC bends nicely. So they used that and they took it apart and stuff, but it's just your setup and your storage at that point.
This is just one way to do it, but we wanted to show you this because this is a great way to start talking about the gravitational pull planets have and what's going on with the sun and the moon and our Earth.
Yeah.
Here we go.
Cool.
Any questions about that one? Now, there are tons of videos online you can look up if you're looking for different detailed explanations for different aspects.
Don't we have the one link off of there?
I haven't put it in there yet.
Okay.
No, they like showed it, but they didn't say what it was. I haven't looked it up.
Okay.
There's too many other things to do. And we'll put a link to a couple eventually. I haven't, just because I had other things to do. Oops, sorry. Here with marble. But it's obviously a lot we can teach with that. It can be a lot of fun for the students to be able to explore. And so, but that's where we started off the middle school workshop that we did with that one, and it was a really good hit. The teachers really enjoyed exploring with that, and they seem to find a lot of uses for that. But now, there it is. We don't need to see my email,
You don't need to do that.
huh? And so the next thing is the exoplanets with Arduinos. Do you want to kind of explain that?
Yeah, I'm just going to explain this one and we'll explain why. You can look in there and there's a teacher handout, there's a student handout. If you've had any dealings with Arduinos, and there is some setup on this, you have to be able to get the right Arduino, and then you have to download the right sensor for it. But once you have that done, the rest of it is basically kind of here. But getting that part is still kind of a
If you're used to, if you've used Arduinos and you have those, I think you used the Nanos, if I remember right.
It is the Nanos.
And so if you're used to those, that's a really good lesson to explore. It's really neat, really talking about exoplanets and how the transit theory, how we've discovered and how we know exoplanets are there. And it's a neat activity for that. If you're not used to using Arduinos and comfortable with that, save yourself the headache unless you have someone to really walk you through that.
So if you don't know what an Arduino is, it's basically a little computer chip that you can have collect data, and it can go straight to your phone. And so you can actually have the kids collect the data on their own phone. So what you're seeing in the picture on the left is a light bulb, and then or on the right, yeah, a light bulb, and then what we do is we have a little
Marble
no, it's a wooden ball that we put a
string.
man, I tell you what,
We just have like a little marble. It ended up being a wooden ball, but it's like a marble thing, and you're rotating it around just like a planet will rotate around its star. And it's looking at that very, very small amount of difference. And like Bill said, the one on the left, if you look closely, you can actually see the dark spot. So you can see where that photograph was taken. Wow, someone's like a good picture taker.
So what happens is this is the Arduino right here, and then you're going around this light bulb, and as you go around the light bulb, when you go in front of here, it blocks the light. And you can actually see where it blocks the light on the sensor because it starts to block it. And then the questions start coming out of the kids. Well, what happens if you go slower? What happens if you go faster? What happens if you go a bigger distance around the sun away from it? And then so they can kind of play with like, okay, if I get really far out, eventually I could have a total eclipse because I am close enough to the Arduino, the one that is actually sensing the light, and you can actually fully eclipse the sun. And so it's an activity to look at that entire process of those going around the sun and being blocked.
There you go.
And it gives you an actual data collection of looking at how much light is coming from the sun, the light bulb to the sensor.
If you have sets of Arduinos and you're used to using those, check it out. If you don't, my 2 cents is skip that.
Our Arduinos are about $35 a piece.
Well, there it is.
Yeah, they're about $35 to $39, somewhere in that range. So, and then they just need a light bulb and a ball.
Yeah.
Marble.
Whatever.
One last thing I want to tell you, if I,
Sure.
when you were, if you do this, one thing that we found that was kind of cool is if you put like a piece of paper behind your sensor, then you can see the shadow of the ball onto the sensor itself, because sometimes the kids have the sensor or the ball up too high or too low. And so if you have that paper behind there, as you go in between, you can see the shadow on the paper, and then whether it's on the sensor or not. That would be my only little 2-bit of like, if that's something you want to go down the path of, that's kind of a nice thing to know.
There you go.
Let me see if there any questions about.
You got the chat up.
I do.
That's about it.
Okay.
All right, next thing we want to talk about is safely observing.
And eclipse, yes. Let me grab the pinhole viewer.
Go on, you start.
All right. Okay, so we are going to begin with some solar eclipse safely observing it using glasses. It's not just any glass, and you want to be careful about the safety glasses that you're using. They need to be approved for directly solar, directly viewing the sun. We found some eclipse shades. Not that, can we say where we got them or
Yeah.
no? Okay, I was gonna say, not that we're plugging any one place or another, but I think we ordered them directly from rainbowsymphony.com. That was pretty reasonable, I think, with those. And they're not the same as sunglasses. So I think that's really, even like polarized sunglasses, anything like that. We're not using sunglasses for observing a solar eclipse. And really, even there's some, you need to be careful, even like if you have welding glasses, those really aren't the same that you want to be using. It's specifically
Yeah,
the
they're not quite
eclipse
as
shades.
powerful as the eclipse ones.
Right.
The welding glasses aren't quite as powerful, and it can still let wavelengths go through that aren't safe.
Right.
I found one website that said eclipse glasses were 1,000 times darker than your normal sunglasses.
Okay.
But then when I got to the NASA website, there was an S behind it. It was thousands of times darker
Okay. Not just 1,000 times.
than regular sunglasses. And so I liked that when I found that on the NASA website, because when we talked to elementary, when we introduced
Yeah.
this, I kind of did it with my teacher hat on,
Mhm.
talking about, if it's over 1,000 times darker than sunglasses, we'd have to wear 1,000 pairs of sunglasses to protect ourselves.
Right.
And we just couldn't do that. That's not practical. And so one little sheet filters out and allows us to view that. So we want to be safe. But what happens if we don't have those, or we don't have enough for everyone?
Right.
We still want people to experience that. And I know something I did years ago, the box, was the, I used a shoebox back in the day. How did we do these?
But these, we took a cereal box and we made a pinhole viewer. And for this, what we did is we placed down on one end, we placed a strip of paper from one side to the other. We taped it inside, and that's where we're going to be viewing our sun. And then on the other end, we cut 2 holes. One hole we're going to leave for us to be able to view on the strip of white paper that's taped inside. The other hole we covered with a piece of aluminum, and we used a toothpick, or you can use a just anything. Like I even saw mechanical pencils, the lead from mechanical pencils. You can use that just to make a really tiny hole. And what we do with that is we put the sun. So the sun is behind us, so that our back is to the sun, which adds a layer of safety, because now you're not staring directly at the sun, your back is to the sun. And we want to line up the pinhole with the sun, and that's going to project the sun onto the strip of white paper that you've taped down at the bottom. Then you're able to view this hole, you're able to see the sun itself.
So you're telling me that if Steve's head is the sun,
Steven's head is the sun. Yep. Okay.
everybody with me? All right.
Sound fairly bright.
So that I'm going to be
Sure,
looking,
that's what
I'm going to
you
be looking in here,
Yes.
because Steven's bald head, with being bright as it is going to then
Yes.
go in there, and then I'm going to be able to see.
And then
it.
you're able to see the sun projected onto that strip of white paper at
Okay.
the bottom of the cereal box. And it doesn't have to be a cereal box. Any cardboard box or
Yeah.
box that you can cut into is going to be just
We used like lunch boxes
Yeah.
from like
Yeah.
Subway, Panera, all those places.
Yeah.
We made them out of those. I love these, especially coming from the elementary side.
Yes.
I love these because some of the viewers, this way they are not looking at the sun, just the opposite. The sun's back there behind them, and they're not accidentally looking up at the sun.
Right.
That's what I love about this type of viewer.
The thing about this type of viewer is the sun that's projected onto the white strip at the bottom of the box is small. I mean, you can see it. It definitely is the sun. It's probably, I don't know, a couple of millimeters across.
Sure.
It's not terribly large. So to get a larger projected image of the sun, you would have to increase the size of the box that you're using. So we got a much longer box. And you're gonna see this one, the dimensions are, I want to say this is a 5 foot
Yep.
long. What we did is we completely removed, well, actually not completely. What we did is we had, for the flaps that were forming, we just shaved off about a 1/2 inch so that when we taped them down, it made the inside, there's an opening on the inside. We taped a piece of aluminum foil over that and then poked our hole through there. So you just only need a little bit of an opening because then that's where your pinhole goes. But then opposite of that end, we cut a hole in the bottom. So the clear other end is where we have our pinhole. This end, we cut out this viewer side, and then we taped a piece of white paper to the bottom small end of this, so that that's where our sun is getting projected onto. For this,
So now
go ahead.
the hardest thing with this is, so now you got to point this end towards the sun.
Yes.
So this was kind of fun when we did it, because, so if Sarah and I are partners,
Yes.
Sarah can kind of hold it and look and see, okay, and then I can get down below and look inside the little hole that's on the other end to see the sun.
I had students putting it on the ground.
Yeah.
With the teachers when we did
And
it,
then lean it.
I suggest putting it on the ground and then just leaning it appropriately. What I don't like about this is you're trying, it takes a little to get it lined up right. And even I glanced, just talking about get it lined up right to see exactly where that is and get the sun right down in the viewer. It's so easy to look up to see where that's going to be. And so I that's what I didn't like about this. I know David had put,
Toilet paper rolls.
yeah, he put here, hold that, I'll grab one.
So he's going to show you. So they put toilet paper rolls, and it looks like it's a viewfinder, but they didn't use it that way.
Yeah.
You have the toilet paper roll here, so then you can hold it.
And toilet paper. With paper towel or something.
A paper
Don't use toilet
towel.
paper rolls, that's disgusting.
A paper towel roll.
I think
No, that's disgusting.
I think I would use whatever they have. I would.
But here, they put it here. And the idea was, now the idea behind it, you're saying, as you look, don't look through it,
Yeah.
but you can see whenever you can see the ring, maximize the ring
On the ground.
on the ground. That's when you're lined up with it. I still hate it, especially that I hate even more because I really want to do this.
Well, that's the gun. That's the gun shooter in you.
Well, that would be this.
Right, bazooka.
Yeah.
But I will tell you this: when we did it with the teachers, the ones that were able to do that and have it line up on the ground,
Mhm.
they got it to looking at it the fastest. And so you think about, you only have how long the total eclipse.
Depends on where you are in it, but anywhere 20 seconds to 3 minutes.
So, I
3
mean,
minutes.
If you have kids during that time, I think being able to get that lined up quick, if you're going to do something like this, is kind of important. Because you don't,
Well, you practice this ahead of time.
right.
Because you can see the
Yeah.
sun. And you use I don't know if anyone asked you yet, I expect the question to be why aluminum foil on all of this? And we use a toothpick to make that opening.
Can you unshare your screen so we can see the demo better? Oh,
Oh,
thank you. Okay.
well, that was,
That was smart of whoever asked that.
Yeah, thank you.
Thank you.
sorry.
Oh, wait a minute. Nah, that was Andy. That wasn't that smart.
Oh, no.
Come on, Andy. Okay. So can you now see it? Is that better? Okay.
Sorry. What were we saying now? I forgot.
Do we need to redo it? No? Okay.
They're like, no, shut up and keep going.
All right. So you can see but you see the viewfinder there, and you can see the hole in the bottom,
Where's the other?
Yeah.
and
So
then,
we'll say,
Why did someone say that earlier?
from observing with the cereal box versus observing with this, this is a significantly larger sun that's projected because of the distance that you have between the pinhole and where it's being projected.
And this is significantly less tempting to look into the sun with.
Exactly. So you've got your pros and your
The
cons.
middle school kids, they never fall into temptation, so it's a
No,
great
no, no.
idea.
and I bought these boxes at a shipping store locally, and these were only like $2.10 a box.
Okay.
So this weren't that expensive, which was kind of
Yeah,
nice.
this was, you tell people bring in leftover boxes, so it was nothing but a sheet of aluminum foil.
Now tell them where you actually got those.
Where
Well, so
we asked my wife asked her school, said everybody save boxes for Stephen.
uh-huh.
And one of the ladies said that her Girl Scout troop was going to
Peaceful Primates
Peaceful
in Winamac, Indiana. It's where they retire medical primates that are used in research labs. And they have this nice retirement home for them. And we had no idea it was there. So we took a trip up. We got to meet some chimpanzees. And
We
they
had a
were
teacher from Winamac that came to our in-person thing, and she didn't know it was
She
there
didn't know it
either.
was there either. She was very impressed. And yeah, it was pretty exciting.
So yeah, and they use it was like they do tours and stuff for groups.
Mhm.
And so when the scouts came, the entry fee for the kids, they all had to bring a box of cereal, and they use that for their what they call it, monkey chow.
Monkey chow.
They use
no
that
idea.
for their
Yeah.
treats and stuff. So they had a ton of those.
Yes.
So they gave us their that's stuff they didn't care about.
Something else I wanted to, I had thought of it and then I got distracted. I don't know why, but with our
You're usually
class,
distracted.
with
You
our
might have a problem.
with the eclipse glasses, I know that right now NASA is fully saying at this point, it's never safe to take the glasses off because we're coming up to the annular eclipse, which is not the same as a total eclipse. The first eclipse we'll experience is an annular eclipse, at least here in Indiana, where we are. We will only experience an annular eclipse in October. And because the moon will not completely block out the sun, it will never be safe for us to completely remove the eclipse shades. So once that this first eclipse in October passes, then NASA will change how they're describing things. And during totality, when the sun is in the path of totality and the moon, so the way the sun and the moon are all aligned, at that point, then they encourage you to remove your eclipse shades and observe it with the naked eye. But again, right now, the stand is you leave the eclipse shades on the whole time until we get past that annular eclipse.
Okay, so
That makes sense. Yeah.
You want
so what you're telling me is
Mhm.
if it's a total eclipse,
If it's a total
I
eclipse.
can take them off when it's a total eclipse.
When it's,
if you're in the path of totality.
if you're in the path of totality.
Yeah.
Only.
And only if you're in the path of totality. Until it hits totality, you have to keep the shades on. Even if you're like in the 93%, that's not enough to remove the shades. That's still going to be too dangerous for the naked eye.
But tell them about the plate thing that Jessica does.
Oh, okay. Some of you may have seen in 2017, you might be familiar, but you can take a paper plate and they have a pattern where you can fit the eclipse glasses. You
Yeah, you put it there, draw it,
put
cut
it
it out.
there,
You don't need
right.
a pattern for that.
Yeah, right. And this kind of then creates more of a barrier around it. So as they're wearing it, they have just more, it's not as tempting to kind of pull them down and see and then put them back on. And you're trying to eliminate those chances that students might remove the glasses and look at it when it's not safe.
So for impulsive, and they get to decorate it in that's their sun eclipse thing decoration.
Yeah.
And so it's kind of fun for them to be able to decorate it so you don't realize, or they don't realize at that point, you're just really trying to keep them from hurting themselves.
Other types of pinhole viewers, we have some, there are definitely some printable options up that you can use a hole punch. One that we have that was kind of pre-made and it was a globe observer.
Was it
Well, yeah,
kind
it's
of?
definitely pre-made. Yeah, definitely pre-made.
Well, you said kind of.
I know, I'm just talking. Definitely pre-made. It's got a pin or a hole punch in the center and it's being used. Again, the way that you would utilize one of these, the sun's to your back, so you're never actually viewing the sun, and you'd hold a sheet of paper out from it and you kind of line the hole up with the sun and it projects the sun onto the paper. And with all of these options, we're encouraging using these before you would ever get out into an eclipse scenario so that the students are familiar with it, the students know what they're doing. And even if you won't have students that day, it's still helpful to walk them through the whole procedure prior, because then during the eclipse, they can help family members with safe ways of viewing the sun.
So one of the things we haven't talked about with this, Sarah mentioned it again about practicing ahead of time. One of the things you can do in the classroom, which I think is awesome, is have a light bulb in the classroom and then use any one of these techniques that we did. Probably not the long one because that's going to be, you'd have to be
It's a little dim.
a little bit hard to see.
It's a little dim.
But it's cool because then the kids get to see that the image is flipped.
Well, they won't see it with these.
Yeah, the way this one's designed, it wouldn't be. It needs to be actually, no, it
We,
would.
we did
No,
it with
it
those.
is.
We did it with those. We did-
Well, it would work this way too.
You can still see it?
Yeah, you can
Yes.
still see the reverse.
Yeah, we did it
image.
with both.
Yeah. The idea, it's a pinhole camera.
See with it.
Yeah.
Okay.
Yeah.
I don't know if I believe the two of you, but both of you are saying it's true.
It is. It's a pinhole camera, and actually this one too. Yeah, but even the long one, it's the reverse image. And so the way the pinhole camera works, it's reversing the image. So when you're watching it on that strip of paper that you have, when you're projecting it there, you're seeing the opposite of what's actually happening in the sky, just because the image gets reversed.
And when the kids are out looking at the sun, if you
Mhm.
practice looking at the sun, it's not like they're going to look at it and go, "Oh, look, the sun's upside down."
Yeah,
I mean, they're,
because it's a sphere there.
yeah. But if you
Yeah.
use a light bulb, then they can physically see, "Oh my gosh, it's upside down."
Yes.
That creates some more conversations you can have as
Mhm.
as to why and that whole thing.
Light images, how those reflection, how that's happening. There's another activity through my NASA data where they talk about using some different shaped holes. So here we just have a regular hole punch through this viewer, and it's exactly how we would expect it to see. What happens if we change this to a star hole or a triangle or a heart? And so that's kind of a fun thing to ask the students. What do you think that's going to do to the shape of the image of the sun that you're observing? Something else is using a colander. I think I've seen where you can use a colander behind you and project that onto some paper. You could even crisscross your fingers and kind of make some squares. I know they even talked about in 2017, I remember them talking about leaves of a tree. So you could view the crescent shape through being filtered down through the leaves of a tree. And I viewed that when I was here on campus. But thinking about how would that change the sun that's projected, the image of the sun that's projected onto paper. And I didn't know. And we asked, is it okay? Can we just say that now since we're.
I have no idea what you're going to say. Sure.
Yeah. So it doesn't do anything to the image of the sun that's projected. You're still, no matter what the shape of the hole, whether it's a star shaped hole or anything, you're still going to see the circle sun, like the sphere shaped sun. It's not going to change that.
Doesn't change.
Now,
Spoiler.
yeah, right. If you didn't know, now you do. Now, we got to looking at that during the workshop, like, yeah, but if I hold like a triangle with my fingers and then I'm seeing a triangle shadow on the ground. Well, the difference with that is it's a much larger shape that you're doing, and it's the way that you're going, that's more of a shadow projection. That's not really working like a pinhole projector. So at that point, the perspective's off a little bit, I think. So you would see those shapes. But if we're talking about a pinhole projector for that, it's going to be the same no matter what the shape is.
Any questions on that? On viewers?
Any questions or thoughts? This is that teacher wait time. Remember, you had to wait 5 seconds, count to 5, and then before you move on. Okay, we counted to 5.
Count to 5.
I did.
All right. All right. So as you can see with our teachers, your students be the same way. Everyone was trying to figure out which way to point this thing to get to the sun. I caught that on camera, which was hilarious for me. But yeah, it's like, all right, everybody use it. And they're all like, okay, which way do we go? And well, in the workshops, physics astronomy has telescopes, special telescopes with solar filters. You can get those for cameras or telescopes, but they had a specialty solar filter, just like with our lenses that we use specialty solar filters on those to be able to look at the sun. Obviously, you never want to actually look at the sun. The next thing we want to talk about is the scale model of sun, moon, and earth. With this one, we have a link there and an introduction. And I'm going to take it off the screen for a second so Bill can show you and talk about the setup of this. Is that all right, Bill?
Yep.
Good with that?
I'm ready.
Okay.
Okay. So with this comes, so we found this, getting a massive, this is a balloon, believe it or not. This is a massive balloon, okay? You can get different sizes. This one just happens to be, it can go up to 5 feet across, okay, a diameter of 5 feet. And so it's pretty big. But this works great for a lot of reasons. And I'll tell you this, the balloon was about, I think they were about $30 for one balloon, but these are pretty hardy. So what we did is, I'm just going to put this back down, but this is the balloon. We bought a simple, you can get these pumps anywhere. A lot of people use them for pools, pool toys, stuff like that. But it's just a pump. Okay, so an air pump. So then what you do is you blow up that balloon and get it about that 5 foot across. We found that if you use these clamps, so these are also, I think these were like $3 at a hardware store, but you got to get a pretty hardy clamp, because when you're done and this thing is all the way blown up, you got to be able, you don't want to tie your balloon because you want to be able to use it again. And I don't know how you'd be able to tie it anyway. They'd have a hard time. But I found that if you just, when you got the balloon fully blown up, if you spin it and then fold it over once and then clamp the balloon, that worked pretty well. So I want you to imagine it's all blown up now. All right. Now, you can laugh at me or you can think I'm ridiculous. The first time we did this, we started off in this lab that we're in, and then you have to go outside because, and I'll explain in a minute. You need to blow these balloons up outside. Getting through the doorways is impossible. So I could not, so here I am, I got this balloon, I was all excited, and then I couldn't get through the doorway, so then we had to deflate it, go back outside and blow it back up. And I went, that was stupid. I don't ever want to do that again. So now you have this massive balloon. So before you go outside, and this tells you on the instructions, if you go outside and you measure, and you can measure different feet, it's up to you. You can play with this however you want. I think we did 40 feet, I think is what it was. So you want the kids to come up with what is their stride length. Okay. So what we did is we measured out on the hallway, and we put 2 pieces of tape. And the kids would then start on 1 piece of tape and just start walking, okay? Walk normal, but count the number of strides they do for 40 feet. Do it 3 times and then get whatever their stride length would be based off of that. So that way they know when we go outside when they eventually measure, because you don't want to take a tape measure and go, because we're going to go probably almost about 230 yards away from this balloon in order to do this activity. Okay. So you got to think about where you are in your area, if this, how you're going to do this. But then what you do is you give each kid a pencil. It doesn't have to be a pencil, but we found that pencil is a pretty good way to do it. And a pen that has let's see if I can get as close enough to it. Everybody see that? So that's the pin it's got a little pearl top on it. Okay. Someone mentioned we probably should paint these black.
Yeah, I said it was hard to see it.
And we'll explain why it was hard to see it. But so, all right. So I'm going to have Steve step back in the camera just a little bit right there.
Without my coffee.
Yeah. No, you can stay with your coffee.
Using my head again.
So I want you to, yes, I'm going to use your head again. So I want you to imagine Steve's head's the balloon. Okay. So now as a kid, I'm going to keep walking further and further away until when I hold this out, my eye is the earth. This pin is the moon. And then his head is the sun. And we got to go back far enough. So the point when I hold this out, the sun is completely gone and it's being eclipsed by the head of the pin. Did everybody?
Yep.
Okay. So the great thing is I was thinking about this. If I was doing this in the classroom, I would want kids, if you have space, to walk different directions. So they're not all walking to the same place. That way they're not all kind of going exactly off of, because it might be off a little bit based off of your, how you're looking at it and all that stuff. But once I get that done, now I'm going to walk back and count my strides all the way back to the balloon. And then on the lesson plan that's on there, then it tells you how to do the calculations, and they'll calculate out and figure out the distance to the sun.
Is it to scale? Is all that to scale?
Is all that to scale? Yeah,
Approximate.
approximate. Yeah. I think that's it, right?
Mhm.
Okay. Any questions on that before I?
Do we want to go out of order and show them the elementary one?
We can?
What's
Yeah,
that?
with the dum-dum.
Which company?
With the dum-dum.
No, yeah, we'll have Bill.
I can help. I don't like being called a dum-dum. Other than I did make a dumb thing. Okay. We good? I don't see anything in the chat asking any questions about that. It's a pretty simple, but it's very effective. And a great way for them to start to see kind of, once again, talking about the solar eclipse and being able to see the size and all that stuff. I think the kids are amazed when they have to walk that far away. I would play with them ahead of time and I would say, hey, how far do you think you're going to have to go? You know, and let them start to kind of put in like, hey, I think blah, blah, blah. I think I might make a flat sun. You know what? You could, and then you're only doing it one direction. I think you could
Which
do
would
that.
work just fine.
Yeah, right.
Hang that on the side of the school and walk back.
Yeah, you could do that too.
What we did in the classroom in the elementary, instead of having, was this like, our, a big old balloon and all of that, we did have students making pictures of the sun, which we'll talk about multiple reasons to use these for remote sensing and stuff here in a little bit. But the variation is you can have a picture of a sun in.
And a dum-dum sucker. We posted the picture of the sun that we had made on one side of the classroom. And really with just the width of the classroom that we have, we were able to get a total eclipse using a dum-dum sucker with the picture itself. And then count the number of steps. Now that's probably a little less to scale than the
Yeah,
setup.
it's not a
until-
scale, but it's
right.
the idea behind, so they can actually see what's happening and see the direction. Yeah, it's not, we're not taking the measurements and being
Right.
the scale. But again, it is the idea.
Mhm.
Then we can ask them, okay, so how far away is the sun?
Right.
You know, and so we can go into that distance discussion at that point without them having to take the time to go outside to walk through and
Yeah,
all that distance.
we do have that lesson, but we'll cover it briefly. Yeah, in a few minutes.
When we get through the other one, because that's what we did part of our elementary, but it has really, really good uses to introduce remote sensing. All right, so where are we on the lesson thingy?
I think we're on the moon phase board.
Okay.
Oh, that's,
Phase of the moon board.
I got. And I would like to ask you to stop it. See you. Lock it up.
I'll ignore you.
Okay.
All right, so the next thing we did, oh, wait. Oh, I'm on that,
Close out of
I'm
this.
on that other page. Oh, yeah, that's the one we just talked about.
Yes.
And with this one, and you can see the pictures of exactly, here's all the teachers with their pin heads.
Mhm.
And then this is them pacing, they're counting their paces till they get to Bill that was holding the balloon.
And this is why they had recommended, with the balloon that we have is white, and then they were using the pearl pin to try to eclipse that when they were so far back,
Yeah,
trying to find that, that eclipse point with the white pin and the white balloon was a little tricky. So they had mentioned, well, you might even try like the different colored pins or a different colored balloon, you know, so they weren't both white.
and I will say, when I took this picture of them walking, I was halfway.
Oh.
And so it was twice as
Yeah.
far as this. It was a good distance. You need some real estate to do this puppy.
I'm thinking parking lots.
More than a
Yeah.
football field.
Yeah.
Well, it's 200, yeah, it's 2 football fields.
Yeah.
Mhm.
And so you need some distance to do the full one. It was cool. You know. All right. So the next one we want to talk about is the moon phases board.
Yep.
And we do have a link also to that one.
Yes, we do.
And do you want me to jump out of it, or do you want to walk through the
You can just
lesson
walk
part?
through the lesson part here
I'll
and
give you
then
that.
we'll jump out. This one, we had a couple of graduate students had found a lesson. They were trying it for another program that we do, but we have a video of them showing, you know, making the phases of the moon board. And then we have a camera view in this, and the link to this video that we have here. This was also part of a Passport Day program that we did. It was also part of Kids STEM degree, which we can talk about later if you're not familiar with the Kids STEM degree. It's a Superheroes of Science program. But this, idea phases of the moon board is to give you a firsthand account of the phases of the moon. So you get to actually build it. It was really fun to build this. The idea is that you have a foam board. We used a 20-inch by 30-inch foam board. We cut a hole in the center large enough that you can stick your head through it. It took 8 little ping pong balls. And what we did is we colored half of the ping pong ball with a Sharpie marker. The other half we kept white. And then we took a piece of yellow construction paper and we made the sun. And then we lined up all of the ping pong balls so that the white part of the uncolored part of the ping pong ball was facing the sun in all 8 positions. This threw me off a little bit before I actually did it. When I was making it, I thought, wait a minute, this seems kind of weird. Now, looking at this picture that we have, I have the labels placed here just so it's easy to read. I think when I go to make it on the foam board again, I would move the labels so that they were all facing in, so that as I had my head through the hole, I could easily see the phase of the moon that I was looking at. Then this took a little bit of time playing with it because we want a counterclockwise motion to view the phases. And so very good. So as we are viewing through this, the idea is now Stephen's moving the board. And so we're able to view these. But the idea when we're doing this, we want the board to stay still. So I think the way that we wrote the procedure, we would like 2 students to hold the board steady and then instead have the person with their head through the board should be moving their head or their body counterclockwise to view the phases of the moon so that they view them in the correct order. Beginning with the new moon, they would see the ping pong balls completely blackened. If they're turning their head counterclockwise, the first thing that they're going to view is a waxing crescent. And then if they continue turning their head counterclockwise, then they'll get to, get this out of the way here. Then they'll get to the first quarter, continue moving counterclockwise. Then they get to that waxing gibbous. When they have their back to the sun, now they'll be viewing the full moon. So we tried a few different configurations here. I think when you're moving, if you're moving the board, if the person inside the hole is just standing still and you're moving the board counterclockwise, you'll actually view it opposite. So then we tried moving all the labels over and still moving the board, and then we weren't getting the right side of the moon shaded or showing up illuminated correctly. We were seeing it as if we were in the southern hemisphere, which is fine. But if we wanted to see it how from the northern hemisphere, I think the way that you're going to get the best results is to have the person with their head through, turning their head counterclockwise to view that. Okay.
The single ball one, we have a video of that one.
Yes, we do.
That we've done that both from first person perspective and third person.
Yes.
And so we have a video. We've done that for workshops in the past. But then would you need to elevate the balls to avoid an eclipse during the full moon phase? You go off the screen.
You said you would need to.
Oh, you said you would need to?
You would need to. Yeah.
I don't know. I don't see it now. Oh, is he just sending that to you?
Yeah.
He just sent messages to you. Secret messages going on. With this, the sun, the flat sun, you're not going to see it anyway.
Yeah. There's our.
You'd have to elevate the sun, and it'd have to be prospectively smaller. Which I suppose if you put this in combination with the, am I rotating it the wrong way again?
No, I think.
If you put this in combination with the, putting the sun thing up here, the picture of the sun talked about, what are you doing, Blake? That would work.
Okay.
Good. What's this? Oh, the single moon.
Yeah.
We have a video of that, of the single moon one, if you want to see about that one on the Superiors of Science website. How many people subscribe to Superior Science on the YouTube or podcast?
Only one, me.
Ouch. Well, I do.
So I'm going to give you a link for the Superheroes of Science So all the videos that we have that go along with all these lessons are housed at the Superheroes of Science YouTube channel. And highly recommend you go in there and subscribe, not because we want to get more subscribers. We do.
We do.
We do. But it also makes it easier to find later. It also has, we're only giving you one part of what we do. There are multiple things that we do that are outside of professional developments like this, that you could go in there and get tons of resources. And we'll spend a little time at the end going through the resources that are on that. Right?
Yeah, we'll show you
Okay.
some of the different programs that we have.
I mean, and sorry for those of you who are new to this. There are certain people who are at this right now that we've seen year in, year out. Thank you for coming back. That speaks volumes for you guys.
Except for Andy.
Andy
So-
may give you the toughest time.
We love Andy. Come on. So I think it's those of you who have been here again and again. I mean, thank you. But those of you who are new, the Superheroes of Science, please subscribe. All right, go ahead.
All right. Ready for the globe
Yeah.
training?
We'll go through globe stuff.
Okay, yes. Okay. We have a couple of it's global learning and observations to benefit the environment. It is an international program. It is sponsored by NASA and funded and supported by NOAA and the Department of State. The Department of State is involved because it's in over 120 different countries, and it's very exciting. It's being a NASA-sponsored program. There's an opportunity for the citizen science / data collection piece that can get anybody interested in the process of science actually involved in that process. So the idea is that we are ground truth verifying NASA satellites, with the satellites outside taking pictures, looking down, and then we're here at the surface of the Earth looking up, and we're making these observations and uploading our observations into NASA databases that are then freely available to anybody that would like to use them. NASA scientists, research scientists anywhere throughout the world, citizen scientists. And so it's a powerful thing that then students are able to help contribute data that then real scientists are using in the research that they're doing. We're going to talk about a couple of activities that are available through the Globe. I think these are just available on the Globe site. And then we'll talk about how to become trained, if that's something you'd like to do, and why you might want to be trained. So the first one that we talk about is an activity. It's called Why Not So Blue. This is a learning activity that is affiliated with Elementary Globe, but we use it with students of all ages, including high school students. I think this is a really cool activity for explaining why you might see a different colored sky on different days. So if first of all, the link that we open goes to the Globe, the way their actual protocol, their actual activity, that they have it all listed out. So the idea here is that we look at how to do it. It's affiliated, like we said, Elementary Globe. There's a book. It's What's Up in the Atmosphere, Exploring Colors in the Sky. For this, we have a sheet, which will show you a link to a placemat that we have that was specially developed. We have a link just for you that we received during the middle school in-person workshop. But you want some glasses, some clear cups that you're able to look through. During the professional development, the in-person one that we did, I think we used some clear Petri dishes. It's anything clear that you could observe through. What we did is we filled each of those with some water. It doesn't have to be any kind of special water, just water. And then we added some drops of milk to each of the containers. And then we were able to look at them straight on a blue mat. So even if you don't have the mat, you could just use a blue sheet of paper or just any kind of blue background. But then we also looked at them not just straight on, but then also through the side of the cup to look kind of like we're looking through the atmosphere, right? Like how cloudy is that atmosphere? The ones that we're looking at you're going to see no milk. This was kind of a discussion during how do you get half of a drop of milk? This is actually a really precise thing. If we're using an eyedropper, or if you have a little plastic pipette or something, when you have a drop of milk hanging from the dropper, you use another dropper with just plain water and you kind of shoot that little drop that's hanging into the thing. So it didn't fall on its own. The drop didn't fall on its own. You force the drop out. That's half a drop of milk. Technically, that's what that is. Other groups said they just modified it to where they maybe did like 1 drop, 2 drops, 3 drops, 4 drops. I mean, it's however you want to set it up, but I just wanted to explain what that half drop meant. Now, if we go back to this and we look at the mat, that you're going to kind of see a picture here where we have it set up. The mat is really cool. It does get printed out. I want to say 11 by 17 paper. The thing is if you do this mat, you might, depending on the glass that you use, the plastic cup that you use, you might not be able to get all 5 of them listed the same way. It's taking just a second. The image itself is pretty large, but there we go. So now you're going to see each of the ones. If you have no milk on it, you're going to see this deep blue color, and you're going to see the same color of blue all the way through, but then depending on the amount of milk in the water, it's going to cloud that. And we should be able then to describe how these particles in the atmosphere create this haze that it's going to affect. It's the aerosols that are affecting how blue the sky is that we see. There are some other activities along with this on the Globe site. But it's just it's neat to see this. And I think the kids have a lot of fun setting it up and then making those observations. The next one that we did kind of in preparation for the Globe training that then we did, which we'll talk about, is an estimation activity. And one observation that you'll be able to make with your students during an eclipse, if there are some data that you're looking to collect, or if you're curious, what data could I collect during a solar eclipse? One of those observations would be a cloud observation, which we can do through Globe Observer. And to prepare for making a cloud observation, we have to be familiar with estimating the amount of cloud cover in our sky. Now, the whole sky is not our sky to observe. What we want to do is we want to observe our sky, which we get it. It's kind of at an angle, but you're going to put your, thank you for stopping that. You would put your arm out, and then you'd put a fist above that, and then another fist above that, and then your fingertips, everything from your fingertips up would be considered your sky that you can observe. And then everything from your fingertips down would be somebody else's sky, just with the curvature of the earth. But looking at your sky that you're observing, we want to know how much of that sky is covered by clouds. And there is a globe right up for this activity. Different percentages of cloud cover go with different terms. So if you've ever heard scattered, that's a meteorological term that will be used. That corresponds with a certain percent cloud cover. There's broken clouds, there's overcast, and that goes with a certain percentage of clouds that we have. But what I really like about this activity, we use a blue sheet of paper, just regular cardstock is what I have, and then a white sheet, 8.5 by 11 sheet of white paper. And you can scaffold, you can give students a percentage to try and do. Or you can have the students come up with their own percentages. And again, it kind of depends on, your class, what's going to help them the best. But the idea is for this one, if I hold this up, what percent of the sky is covered by clouds?
Should we have them type it?
Yeah, type it in. We'll give it a minute here.
Type in what you think. This is kind of a fun game to play.
Oh.
There are only a couple wrong answers. No, I'm just 25, 30, 65, 50, 40, 50.
All right. The first guess was correct. If you had 25, this is a 25% cloud cover, which is kind of funny. But then to prove it on the back, we always have them show the proof on the back, right? So we had used a quarter of that. That we use, and you don't use scissors. We don't ever have sharp, perfect clouds that we have. So we kind of tear it. We use a glue stick and we glue it on. And then, like I said, we always show the proof on the back. I think this is a great way to work estimation in. We always need help. You can always use more practice with estimation. All students can. If you're not able to do this one in person, there is also, do we want to see another one before we jump to that?
That one's not valid.
Okay, yeah.
They didn't follow directions.
Yeah, this one's
Because you don't want to overlap them,
You don't
You're not
overlap.
allowed to overlap anything.
but
Yep.
Some of those are slightly overlapped.
The other thing, you want to be careful that the paper doesn't get sheared. Sometimes when you're ripping the paper, and students will do that, they'll get like a really thin sheet of paper on both. You tried to separate it, but you end up like having more of the white paper than what you started with because it's like you're kind of splitting the paper in half,
yeah,
like
at an
thickness
angle.
wise. Yeah, and so then that can cause some error with it as well. But if you can't do this in person or you want an online version of this, Globe also has a virtual version of this. And we open this up. You can choose, if you want all the same size circles, if you want various size circles, or then they have their cloud cover estimation. Here are the different terms that are associated with those percentages. And so this is kind of a fun one to go through and teach kids about, the different, how to estimate your cloud cover in your sky. Okay, I'm gonna close out my tabs here that I have so far. So then we can get to why might I want to be associated with the Globe program? Like what could this do for me, especially with related to solar eclipse? Well, Globe Observer is a free app that you can download both through the Google Play Store or Apple. And you can look for this icon, you get this Globe Observer app. On Eclipse Day, Globe is going to offer a special portal to all. So right now, if you open up Globe Observer app, you would see you could do a cloud cover estimation. You could do, there's a biometry one that you could do. There's a mosquito one that you could do. There's a land cover observation that you could make. And these are all, anybody can do these. You don't have to be trained. This is anyone can make these observations. On the day of an eclipse, they'll have a special button, Globe Eclipse, that they'll be asking the general public to make some observations for that during that day. If you are a trained teacher, you will have additional observations that you could make with your students, that your students can make. And all of this information is going to a NASA database that they're collecting and using all of this information as part of this big campaign to learn more about our Earth and what happens to it when it experiences a solar eclipse. So to get trained for this, you would need to go through what's called an e-training. So we have instructions for the e-training here. Basically, you're going to make a teacher account. We suggest that before you would log in to the Globe Observer app, go ahead and make a teacher account on the Globe site with your teacher email. Once you have that account made, then you can log in to the Globe Observer app using that account. So that's the order that we suggest doing it. If it asks for your organization, you're free to select any organization, but we would suggest using the Purdue University Virtual School, or it might say V School. And that way you're affiliated with our organization. But again, you're free to choose, your organization. And then there are 3 steps. The very first screen you'll see is Introduction to Globe. Before you can do that, it will prompt you to make a login. It's basically a PowerPoint module, and then you go through and you take a test, like a 10-question quiz. You can take it as many times as you want until you pass it. The next one,
Just comment really fast.
Mhm.
Those PowerPoints, those are really good.
yes.
They obviously, it's from NASA, so it's been vetted, blah, 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 but they're really good. And so if you're like the 8th grade where you have some of the atmospheric things and weather, use them. I use some of their
Yes.
slides in my instruction when I teach. Some of the slides and things they have, why would I bother making all new
Right.
when they've done it? And so some of those PowerPoints you have to download for your training to be certified. Those are really useful to be able to use as PowerPoints to be able to teach different things.
I completely agree. In fact, I always think there's way more information on all those than I could ever use with my students.
Agreed.
It's just a lot of really good.
I just steal their slides.
I'm going to just say this right now so that I'm sure some of you out there are going, wait a minute, I thought I was coming to Purdue University for stuff. The reason why the Globe and they're doing all this, both Stephen and Sarah have been very active in Globe, extremely active. And so they're a part of all this that's going on with this Globe. So it's not like we're just pointing you to a site because we found it was cool. These
Yeah.
2 are very active in Globe and have been for years. So that's why we're talking about this.
Sarah's on the U.S. Partner Forum
Yeah.
for the Globe program.
For the Midwest. So
She's the
I'm representing
Midwest representative.
And they don't want to say this probably out loud, but they're both rock stars with Globe. Globe people love them because they're doing all this stuff, but then these two bring it back down to earth for what can be actually done with teachers.
I think
True?
That's true.
That's
Yeah.
okay.
We're going to suggest, so the next thing you would do is, your introduction to Globe, that's part one. Well, actually part one, create your account, part two, introduction to Globe. Then you're going to do an introduction to any of the spheres, it doesn't matter. We're going to go ahead and suggest introduction to atmosphere because of the nature of the PD that we're offering right now. With the solar eclipse, we think it makes the most sense to go ahead and just do introduction to atmosphere, but it doesn't matter which sphere you choose. Then the last thing that you would need to do is you do one additional module listed under that sphere. So we would, recommend maybe you just do the clouds module or do an aerosols module. Just do one of those modules. Once you've done those three, that's the bare minimum you need, then you are a teacher. And then what that does is it will unlock what you're able to collect data-wise during the day of an eclipse. Now, you do have to be trained in the module for the data that you want to collect. So one of the things that's a really big deal during a solar eclipse is air temperature. What happens to air temperature both before, during the total eclipse, and then in the hours after the total eclipse. So you would want to go through and get yourself certified on the air temperature module. Another one that you could do would be the surface temperature module, which is the actual surface temperature of the ground. And there is a specific way that they want you to go through and collect that data. It's not difficult to do, but it's a protocol. You have to do it a certain way, because then that makes all of the data that's collected valid. So then when you're having that discussion with students about data and why you need valid data, so that it doesn't matter who it is that's submitting the data, you can compare all of that data because it's all been collected in the same way. So that's, I think, what we'll kind of leave it there unless you have additional questions about Globe and Observer.
Calibration.
Oh yeah. While we're here, one of the modules, it will walk you through how to calibrate an alcohol thermometer so that you can take an air temperature reading both before, during, and after the total solar eclipse. To do this, we used a couple of different thermometers during our training. This one is an actual calibration thermometer. Oh yeah, sorry, we need to, thank you for remembering. Stop sharing our screen. This one, what we do is there's instructions online for how to do it, but what you do is you just get a cup full of water. It needs to be ice water. I think the ratio is about 400 milliliters of ice to 100 milliliters of water. It's a 4-to-1 ratio of ice to water. And you let the ice water bath sit for about 10 to 15 minutes, just so it can reach that 0 degrees Celsius reading. Once it's set there for about 10 to 15 minutes, then you can go ahead and put your thermometer in, and you want to let that thermometer sit. I think it's for 3 minutes.
Where are you getting this? It's off of the.
It's off of
Globe.
off of the Globe. When you get in there, it's
The
how to
protocol's
calibrate
on there,
the protocol for calibrating it. And it's going to walk you through. Once you've let the thermometer sit in that ice water, I want to say it's for 3 minutes. You take the reading. I think then you set it in for another 3 minutes. And then you take the reading again, and as long as the readings don't differ, and they should be reading right at 0, because the ice water bath should be at 0 by that point, then you know that your thermometer is calibrated. Now, let's say it's sat, you follow the calibration instructions, and maybe it's reading 1 degree Celsius, positive 1 degree Celsius. Well, it should be reading 0 degrees Celsius. So at that point, we label our thermometer, we use a tag, and we put the date, and if it's reading high, I would make my label minus 1 degree Celsius. So that the next time I take a temperature reading with this and I look at my tag, whatever the temperature reads, I want to subtract a degree Celsius from it so that I am reporting the correct air temperature. So we're checking it based on the melting point of water, the 0 degrees Celsius reading. Celsius is not something that's real familiar, and I realize right now we're middle school, so maybe I think this is always kind of a conversation that we have before professional development is, are we gonna do Celsius this time, or are we gonna do Fahrenheit? What are we gonna talk? One thing that has helped me understand Celsius a lot, I was at a Globe training, and someone was leading this. They were talking about calibrating a thermometer and about how to make the Celsius world make sense to those of us that live in a Fahrenheit world. And there's this rhyme, and what they said is they made us repeat it. They said, okay, say it after me. 30 is hot.
30 is hot.
20 is nice.
20 is nice.
10 is cold.
10 is cold.
0 is ice.
0 is ice.
Thank you, Bill. So I love that because that 30 degrees is kind of the time of year, at least in the Northern Hemisphere, right? If we go outside, 30 is a hot day. 30 is you are walking to the ice cream store and it is hot outside and you are just sweating, just walking. 20 is usually about 20 degrees Celsius, usually about room temperature. It's comfortable. You're probably pretty comfortable at room temperature. 10 degrees is when it's like early spring, late fall. You need that extra jacket, that extra layer because it's just chilly. And then of course, 0 degrees is that melting point of water, or sometimes we like to call it freezing point of water for 0 degrees Celsius.
All right. I didn't know if I was going to mention this. So I just got back from Paris
Okay.
last night,
Wow.
and we were over there, and I gave you kudos for that because I told everybody there because it was 32 degrees one day, and my son goes, "Is it very hot out?" And I'm like, "Yes,
It's very hot.
very hot out," and it was hot out.
Yeah.
Yeah.
Yeah. Yes.
I just got back from, Lafayette yesterday.
Yeah.
Indiana.
Yeah.
Our world traveler.
My entire world's within 40 miles.
All right.
There's the link to the calibrated thermometer.
Yep.
And so there's a link to that.
You know, and this kind of brings back another, if we want to link it back to our cloud estimation activity that we talked about. I think Stephen usually mentions this when we do these trainings in person, but here we're calibrating a piece of equipment. We're calibrating a thermometer so that we can use it. We know how it's reading. There's a lot you could say about calibration and why it's important and necessary. But in that exercise where we estimate cloud cover, Stephen talks about calibrating our own eyes. So calibrating ourselves to be able to read things properly. And I think that it's kind of a cool idea. Just the concept of calibration is very important, but many different things can be calibrated for different reasons. Because we just talked about the calibrated thermometer, I'll go back to the up in the air. What we do usually at the start of, like maybe if we would have been in person when we first started, we first did our introductions, we would have sent you outdoors or somewhere in the building if it's raining with a clipboard and some contact paper, and we would set that up somewhere. I'll go ahead and open this so we can see the lesson for it. I think that the Globe notes mention using a piece of cardboard. We found using a clipboard works really nice, but we're going to collect some aerosols. Usually you want to do this for about 2 hours. If you can leave it out for 3 hours, that's even better. Another note is we might want a note on the clipboard itself saying, please do not remove. This is atmospheric testing is happening or atmospheric sampling is happening, because indeed during our in-person training that we were doing 2 weeks ago, we had a very well-meaning custodian bring us one of the clipboards and tell us, oh, I found this. I think that it's yours. Well, yeah, it's ours. And it was so nice. But we did have it out there for a reason. They were very embarrassed that they brought it to us. We didn't, because our teachers started laughing and we're like, yeah, right. This is why you leave that note on. Sometimes they'll still bring it to you because they don't understand. But we have down if you scroll down through that, you're going to see a paper. It has a grid on it. What we'll do is we'll take the contact paper, so it's kind of sticky side out. We might clip it under. Don't tape it necessarily yet or stick it necessarily to the grid yet. We want to keep it sticky side out, and it might even help to use some extra tape and tape down the corners so that it doesn't curl up. And again, we'll keep it out. Yeah, definitely the wind will affect it. We'll keep it out somewhere for a couple of hours just to collect particulates. When we bring it back in, then what we do is we want to do some random sampling from the squares. So we'll take a die, take a 6-sided die, and we'll roll it twice. The first roll is going to tell us the number of columns over, and the second roll is going to tell us the number of rows down. And so then there's a worksheet that then the students will fill out. They'll roll their 6-sided cube. They'll roll it twice so that we get the box that we want. We'll use a magnifier and we'll count the total number of particles in that box. And we'll do that for 10 randomly selected boxes, and then we'll average them. And then that will be our particulate count for our entire sheet of contact paper. And that kind of randomizes the data for students. So there's a lot of good things to talk about data randomization and why we might want to do that for our samples. And then we'll have students go through and present their contact paper, where the area was that they had the contact paper set up, and what their count was and why it might be that, what conditions were there that might lead to that reading. Sometimes you get some really exciting particles that the students have to count. There was a huge leaf that blew on one, and they wanted to know, well, how do I count a huge leaf? Well, that's one. That is technically one particle. Now, these are very large scale particles that we can see with our eyes, which is the point of this activity. But then we can link this then back to that why not so blue activity that we did with the placemat and the milk and the water, and we're looking at that haze, at that total atmosphere, and that haze is coming from those particulates. So even the massive wildfires, and we're still experiencing some hazy skies and some, kind of nasty air conditions, that all of this is connected, and this is one way we can help students start to kind of make sense of what exactly it is that's causing that haze.
Which I think is a good point when you start thinking about when do you want to teach. I mean, we're giving you a ton of lessons here that all are around the whole idea of solar eclipse. So I clearly get you guys get this, but you may want to do something like this way in advance so that when you finally do even start to build your pinhole cameras and you start looking and the kids are like, well, wait a minute, I'm not seeing it very bright, or I don't think, you can start talking about, well, remember when we did this, this is why we did this, so that you understand that we're not just looking through this clear thing between us and the sun. There's all kinds of other things that are happening in between us. And I think that's a great way for kids to think about later, okay, why do we recycle?
Yeah.
Why do you want us not to burn, or why do you want us not to do this? Because of these particulate matter that get out into the air.
Do you want to show the purple air?
Do you want to do that now, or do you want to, when we go through, after we finish this, and we go through, we'll show them the other labs.
Okay.
And we'll do it with that lab. We'll talk about, we have an air quality lab related to this that we teach, that we have online. We'll go through that then.
Go through that. Okay.
I think it'd be best.
Sounds good.
All right.
What's next on the agenda here? That's
Mine Acid Data
the
website.
Mine Acid Data website. That's just something I encourage you to explore. They have a lot of stuff on there. A lot. The solar eclipse maps, you want to pick that up?
Yeah. This is a story map. If you're at all familiar with story maps, this is another tool that Mine Acid Data kind of joined in with story mapping. They give you kind of the intro here, how living with a star can teach us about the universe. They've got various learning activities and things, the benefits and hazards, and there is a link to the student data sheet. Again, you'll see that prompt, all the Mine Acid Data stuff. They're going to put it right into your Google Drive, but they're prompting you ahead of time.
Why that's coming up, I put the link in again for the website. Everything we're talking about is linked off of that website. So if we're talking about something, you're later like, where'd you get that from? Go back to that website link I just gave you again and understand that that's where it's all coming from. And then all the videos are housed at Superheroes of Science YouTube channel as well.
I would say that the NASA story map, if you want to do a dive into that and look at that, you can say you're welcome to. So I don't think we need to necessarily do a full overview of that.
Okay.
That's something that you kind of explore and check out, I think.
Okay. I agree.
I want to give everybody the activities and stuff. Let's go to day of. Let's do a quick talk about that.
Okay. I'm going to switch seats.
Why? You're fine.
Okay.
You're fine.
All right.
Now let's click off of that just for a second, then we'll flip back to this thing. Now the day of the event, I know so many different schools are doing different things. Some entire states are asking school corporations to not be in school that day. Some are, it's dependent on the time it comes over to your state. I know here it's like the total is a little after 3, if I remember right. That's where a lot of kids be on buses in some schools and stuff. So they're deciding what they're going to do here in our state now. But with that, there's just like anything else, there's going to be a lot of baggage the kids bring. They hear all this stuff from family, friends, and frenemies. And there's going to be a lot of baggage. And with that baggage is going to be a lot of fear from the students. And so by teaching them aspects of a solar eclipse ahead of time, hopefully it can alleviate the students' fear from the anxiety that they have in families. And unfortunately, in the classroom, it's something we have to deal with, is that irrational fears. And we will put up, oh, Andrews,
Yeah.
this stuff. You want to explain that real quick? Well, no, that's a sidetrack. We'll put that up in a minute.
Okay.
Or we'll talk about that in a minute. We won't put it up because I haven't made it yet. He's giving us the stuff. Oh, so ring. But we want to make sure that that's why we're doing the viewers early, so the kids know how to all make their viewers. I'd encourage having everyone bring in cereal boxes and then get a bunch of extras, obviously, and for the ones that don't, bring them in, so everyone has those at home, and get as much information as possible to them, because it's literally, there will be in places people that freak out because it's the apocalypse is happening. We'll just say that. And so there'll be all kinds of things happening. And one of the things we're going to encourage you to do is we interviewed Raphael, which is, well, now he's in Germany. He's a professor in Germany. He was at Purdue. Now I don't remember his job title.
Yeah, I
Is he
don't
a
remember.
dean or something?
Yeah.
He's like a dean of a school in Germany now, of a college. But he is a physicist that did an outstanding job about talking about what to expect during a total eclipse. He talks about everything from when you get into totality and the path of totality is what to expect, to it's like one of the things he talks about is how there might be some clouds, a big cloud in the way. Where he's like, just stay where you are, calm down, wait, because with that darkness coming through, we also have a breeze coming through, and
at times that's enough to kind of push some of those clouds away. You're still going to get to view that eclipse, even if it seems like, oh my gosh, I made all these plans and now I'm not going to be able to see it. A lot of times it'll kind of work itself out.
I know the partial or the one that we had here in 2017, it was that way.
Mhm.
Everyone was on campus and bummed out because, we're not going to see it because of clouds. And right as the eclipse was happening, before that shade came through, because we're in partial, we weren't total here on campus. It pushed the clouds right out of the way. It was really cool. It's magical. He talks about everything from that to expect hours and hours of traffic delays.
Yeah.
And so he does an excellent job explaining what's happening with the eclipse, the stuff behind that. I would encourage you to take that video and share it with your students and have them share it at home. Put it in your parent newsletters and stuff like that, because we think he does an excellent job explaining that.
Yeah. It's about 20 minutes long, so it's not a huge commitment of time, and he is very good at describing it. He's very engaging, and we had a great time learning from him.
Student accounts, you want to go to that or not really?
If you get trained, if you do go through the e-training with Globe and you become a Globe teacher, and again, that you can kind of do that, it's self-guided, you do that. You do, as a Globe teacher, you do get 300 student accounts. That's a lot of accounts. I don't recommend setting up 300 student accounts. But the reason why you might want to do this is, like we talked about, the day of the eclipse, they're going to open that eclipse portal on Globe Observer. Again, that's a free app. If you wanted to submit data, that's cool. You're logged in with your login information. But if you use your login information, let's say all of your students have devices and you log in as yourself on all the devices, your account can only upload one data point each minute. So once the first person uploads it from that account, now you can't upload anything else until like the next minute. Whereas if you have some student accounts, they could all be uploading data at the same time. They could all be contributing to that NASA database at the same time and be partners in that data collection, that science data collection, which it's pretty powerful for the kids to feel like they're a part of that.
And we've used that in just atmospheric studies too. We had like a class set of iPads. We had each one set up with its own student account, and we were doing atmospheric investigations.
Mm-hmm.
And that way, it's because we found out the hard way.
Yeah.
Because we had everyone submitting their data and it wasn't submitting.
It just gives them an error message, which is so frustrating.
And so that's how we found out to create a student account for that.
Yeah.
So I don't know if you guys have so the Globe Observer app, did the best I could right there to bring it. I don't know if they can see it or not. But anyway, there's the Globe Observer app. I tell you this, this is fun. And the more I use it, the more so like when you do the cloud observer and you go through and do all the protocols and all that, if your data, now it doesn't mean that you're wrong, but if your data matches NASA's satellite data, either way, you get an email.
Or to the closest cover. You'll
Yeah.
get, as soon as after you submit one, you'll get your email back to the closest satellite time in that area.
I tell you what, I've loved it, and I got my kids now addicted to it because it's like we set it in, and then you want to see, okay, what does that look like? How does that compare? Not only that, but you're getting an email from NASA, which is kind of cool. I mean, that right there is in itself is just fun, and it's just that whole idea of I'm adding to this database, and I don't know, it's a great way, like when you're traveling or you're doing something, what a great time just to go, hey, we got a couple minutes. Let's all get out and do our Observer app.
When my daughter was in elementary, I was doing workshops on this, and I'd shown the app to her. She's pretty new back then. And every day she would walk out waiting for the bus at school in middle school. Every day she would do a cloud cover thing.
That's really
Which I didn't even realize she was doing it all the time until later.
It doesn't take long once you've done it. Once you've done it a couple times, then you fly through it.
Yeah.
You know exactly what they're looking for, so it's quick.
Yeah. The other thing I was going to point out, Bill had said, whether you're right or wrong, and that's exactly right. Sometimes you're going to make an observation, but because we're here at the surface, the satellite that flies over has that different view. And definitely, especially if you have lower level clouds, you might even be experiencing rain. You might have total overcast where you are, but then the satellite data is going to read it as a different sky cover just because, they're reading it differently. So even if it doesn't match, it's just because you have two different viewpoints that you're taking that cloud estimation.
Or you're just really lousy at estimating.
That's true. It could also be that bad estimation skills, but yeah.
I was 12 for 12 during the trip.
Were you?
Wow.
Of course you.
The one in Copenhagen was fun.
All right, I'm gonna get off the calibration.
Okay.
This is the middle school.
Yep.
One.
That's the main page.
Oh, the main page. All right, so let's jump over here to some of the things we did in the elementary. I wished we had time to do in the middle school one because I would have loved. The first thing, myself being an elementary background, we did writing strategy. So the races, if you've done much with the literacy with writing, you've probably already know about the race writing strategy. And so we do races to sum it up. If you're interested in more writing strategies, there's one we've put together. And instead of a literacy piece, we used the Globe Eclipse poster as the engagement piece for them to have an artifact to write from. And so there's that. I won't go into a ton of detail with that. You can check it out if you're interested in some literacy strategies. But the painting of the sun, I did want to go into this one. This is, it was based on, we used it as a remote sensing. It was a little simpler than what we found. They did all the same things, but I'm like, you guys are doing remote sensing? It's just, that's remote sensing. That's what we want to teach for our GIS day stuff. And so, but remote sensing, we do so much. Do we have a page? Did we make a little page for that?
Yeah, right here.
Yeah, we did. No, I've been on.
Look at there. You actually linked to a page that you made.
Made it
job.
and linked.
How many pages do you have that you haven't linked to?
There's probably a handful
Yeah,
of them out
right.
there.
Yeah. Okay.
There's
I think
probably,
we should take a day and log those, maybe.
it's, you find a day and it's definitely great. But basically, here's a skinny of what we did. You can walk through and look at this later and whatnot. We used temper paint in the activity. You want red and you want yellow. You put a bunch of paint in there, put some soap, dish soap in there. They say not to use Dawn because it takes grease and soap or in paint out of the way. But I think we used Dawn Ultra and it worked.
Well, it just can't have
The blue color.
the degreaser
Uh,
or something. I think it just has to, you just have to read the.
It can't say, okay.
Yeah.
All right. But, okay, I did find, I will tell you, I did find experimenting with this, it helped put just a little bit of water in it. The original recipe that they had, that we took it off the NASA, or the NASA thing, Eclipse page, they didn't have any water in theirs. And I found it worked better with a little water. So, and the way I did it is I had it in pairs. And then one person I gave them names because, it's what we do in science. But in pairs, what do I call them? The paint preparer. See, I'm so creative too. Wow, I'm pretty amazing. You have a paint preparer and then the actual painter, I think, was the other one. And so one person, paint preparer, they take their straw, that's just their straw, and they're blowing a bunch of bubbles. Then the other person takes the piece of paper and just sticks down over the bowl, pops the bubbles on the bowl. And they will get a lovely bubbly painting of the sun. Now they do that over yellow and then they do that with red. So you have two different colors on there. So obviously that's the thing of the sun. And we did use these with the dum-dums to model an eclipse, which worked nicely. But what I liked about that best was the using the cellophane. And so you can use, again, the paper towel holders. We had PVC left over from a project. So we used PVC. It just kind of worked nicely. Put a piece of cellophane over that. And then they used these viewers. Oh, the cellophane that we bought was a little thin. So I had to use 2 layers.
Yeah, we doubled it up and it worked a lot better.
It worked well. And then we had used these as viewers to observe our suns. And by looking at the different sun patterns that we made, yet every one was different, which was really cool. But also, most of them had a corona on too. See that darker edge, a nice corona, the outside part of the sun. And so you could see those, and with the dum-dums, you could actually model, so you could just see that ring around the edge. But looking with different cellophane, you see different things. Remote sensing is about using different wavelengths of energy to be able to obtain different data. This is what remote sensing is. We do it all over our planet and the universe. That's how we know the things that we know. And this was a great introduction to that. Both things we know about the sun, because it's like these different sun filters that we put on these high-end telescopes show us different things about the sun. And there is, I bet I didn't put that on the page, did I? There is, okay, I didn't. The NASA has on their site a bunch of the pictures from the different wavelengths.
We have a Superheroes of Science episode where an astrophysicist that we interviewed goes through and shows different pictures of the sun from an X-ray, infrared view, visible light view. Yeah.
Oh,
which
it's
we
not
can
in
add.
here? I
Yeah,
thought
we
this
should-
was on the original.
Yeah, we'll go through and add that as well.
Okay.
So then they're just looking through these
Uh-huh.
Yeah.
at that.
What's nice is everyone's painting's different that they did. Each group's is different. So we just put those up. It'd be a good bulletin board idea. Just put these up, and we can use the viewers to look at the different ones and make comments. One of the things the NASA lesson has is to use a marker. I don't know if I got that on there or not, to use a marker to make sunspots.
Sunspots. Mhm.
So we can talk about sunspots.
We used PVC pipe because we had some, and I think we already said you could also use paper towel rolls, but the idea is that it's the different colored cellophane, and it's going to block out those different things. that we see.
We use PVC pipe and a coupling, but you can use paper towel roll and a rubber band.
Yeah.
And do the same thing.
You don't like the toilet paper rolls.
Do not ever use toilet paper rolls. That has bothered me my entire life. People would do that. Now after COVID, I think less people would be inclined to do that.
Yeah.
I'm offended that you suggest it.
It's intense.
I'm going to start bringing in paper towel rolls and start putting them all over the place, so they're just there for you.
I hate you.
I know.
All right,
Okay, all right,
let's move
all
on.
right. Okay.
Ooh. It's illegal in California to
It's
use
a-
toilet paper.
Oh, thank
What?
goodness. There's something California got right.
That's funny.
Thank you. See?
Ugh.
It's being recorded. Otherwise, I'd explain a little bit more why that is so disgusting.
Go back to elementary.
Don't you tell me what to do. You're not the boss of me. All right. So I like doing the sun one. And then to talk about the sun, the corona, you want to talk about what we did with that?
Yeah, for this one, this is so simple. And I think all three of us at the beginning, our co-presenter for my NASA data was very excited about this. And I'm saying all three of us were kind of like, okay, it's chalk. I mean, we'll do it. It's fine. And when it was made, in the process of making it and then seeing what was made, it's beautiful. And we were so, in fact, we were just talking before this started this afternoon about how impressed we were with this activity. Yes, it is just chalk and black cardstock or black paper, whatever you have. Do you want to stop? But what we do is we cut out a circle and we use some chalk, whatever kind of chalk you have, and we color the circle, but then we use our fingers or a little piece of tissue or something, and we smear that chalk over around the cutout, and it makes this gorgeous corona. And what's so impressive, first of all, it's just fun to do. But then it's awesome to see this representation of what a corona looks like, and it leads into a lot of great discussion about why a solar eclipse is one of the only opportunities we have to study this part of the sun. Yeah, we have some really fancy telescopes that can also study the corona, but for a lot of us that don't have access to those telescopes, that's one of the only times that we can view that with the naked eye.
Didn't they say there are
During
some
total
things
eclipse.
that is, even with their fancy equipment, that's
Yes.
the only time they can see it is during a total?
Yes, the MyNAS data
Certain
data.
aspects of it.
Certain aspects of that corona, even with those very fancy filters and telescopes, are still only able to be measured and viewed and observed, measurements taken with the naked eye. So again, just that lovely view. They all look different, of course, because we had every teacher making it, did it a little bit differently. The prominences, the little flares, the different things, there's a lot of different names for those, and those are in the slide decks that are available through the My NASA Data resource page. You can learn a lot about those different features. And again, we use those, the paint bubbles activity that we used. You can also kind of start naming some of those. There was a naming activity for those different parts of the corona that you have. You can name those on those paint bubbles pictures that you make as well. Also, like Stephen said, filling in those sunspots on the paint pictures as well. But I think just making and viewing and giving a few minutes dedicated to talking about the corona and that the importance of that corona of a solar eclipse. It was pretty neat to see.
If you say Corona one more time, I'm gonna have to have a Corona.
Corona.
I'm gonna have to have a Corona beer later, just so you know.
I don't think you can say that.
I
I
just said
don't
it.
think.
I don't,
I just
I don't think we
You
can
just
say
said
that.
I mean, it's 5 o'clock.
All right.
All right, moving right along. We just skip the globe stuff. We've talked about that.
Yes.
And we
did
talked
all
about
this.
why not so blue.
Yep.
But what we want to talk about, Sarah's getting all.
Is it getting hot here?
You want Earth Systems page?
Oh, I forgot about that one. I suppose we do an overview of it real fast.
Yeah, because I think we talk about the
Oh,
surface temp-
that's where we do the, yeah, I need to up my game on fixing that.
Would it help to get up and take a breath and change seats? I'm trying to get out of the middle. How about that?
She wants you to take them.
We're getting ready to do wavelengths.
She wants you to.
Yeah, but are you going to talk? You pulled up Earth Systems.
It's only gonna take me a minute.
Okay,
Just
here we go.
calm yourself down. Jeez. Stay in the middle. It's okay. They can
Okay.
still see my reflective head. It's all good.
You're the rose between two thorns, so
Somebody say
you
it.
got to own it.
No,
Somebody say that.
no.
All right, here we go.
On the Earth system. All right. What I like to do is to bring in a radiometer. If you've not seen or used radiometers,
Go grab one.
oh yeah, we have one set now, right here. Let's see it. Stop. Here's a radiometer. They're like $15 if you go to buy one. 15, 20 bucks, something like that, right?
Right around there. You
Yeah.
can get them cheaper, but
All right, they're cheaper in some places. We'll wait a little longer. All right, these are great engagement pieces. I will put one of these on like groups of desks. We'll force students come in and tell them they're not allowed to touch them. Then we'll brainstorm. We'll do a writing exercise. What do you think these do? What are your inferences or what are your observations and what are your inferences? And so that is a great lesson itself, just talking about observations and inferences. But then we start actually trying to figure out how they might work. And so we'll end up shining flashlights on them, and then we'll end up with like a lamp, a heat lamp shining on them. And then they'll spin so lovely, nice. then that leads us here. Yeah, Bill's going to model that for us outside of the camera, apparently.
No, I'm not.
Are you in the camera now?
The camera.
It's in the camera.
Here, is that better if I do it like that?
Yeah,
Right in your
Okay, there you go.
output.
much
I
better.
was trying to do it this way, so I wasn't going. All right, go ahead, keep talking.
All right. I'm gonna-
So for those you can't bring this up quick, this is very simple. It's just there's a piece of metal that goes straight up, and then sitting on top of that is a little glass dome. And then that's connected to these papers that are black on one side and white on the other. There you go. That's a radiometer.
Then what we do, you can put them in a row, and it was hilarious. We did that this time too.
This one.
We used a
Middle
spotlight,
thermometer is
shine.
here,
It's
and the
closest
bottom one is
to
here.
the right, but it shines direct light to the center.
Mhm.
And so teachers were like, what's wrong with the one on the right? And even when we did that this time, people were like, what's wrong with the one on the right?
Something's wrong with it. It's not working.
It's not spinning as much. And we're like, correct. It's not spinning as much.
Yeah.
Nothing wrong with it. And so that's when we brought in and started talking about direct versus indirect light. And it's a beautiful way to introduce
Top
seasons
thermometer
and to
is
talk
this
about
Middle
the sun's
thermometer is
impact
here.
on the earth.
And the bottom one is here.
And so that, I lost the page. Why do I keep doing that? But and this was actually the old Earth Science investigations that we did. This is just how fast will a car warm up. We took my car, we took it up to the parking garage, we parked it in the sun with the thermometer inside it, and as a wireless thermometer, and we measured to see how fast it'd warm up. And so there's a little video on how fast it'd warm up. For engagement piece for this one, we had Leo talking about wanting to take him with me, but couldn't leave him in the car because it got too hot. Then we wanted to, all right, what do we know about the hot car? Lead us to the sun, the energy of the sun. So we talked about this little bit's what's visible. That's what we see coming from the sun. But we have all this types of light, all this energy coming from the sun.
Mhm.
And I love using, I know for years we used slinkies, but now we have these coiled springs that are really long. Yeah, go ahead and grab one. Those are the best things to talk about waves. The best things ever to talk about waves.
What happens when fungus
Oh.
There's fungus.
Concept or idea that
Here's
it's
what we
coming
did
from an
for
energy.
middle
We need
school
to
one
drive
a couple
home
years
the
ago.
wave side of that.
Teaching
Now,
about the using
and
the
most of
slinky
us have
for
used, if
waves.
we've taught waves, we've used like a slinky or something. You can use a rope, you can use a slinky. I really like the spring coils.
Right.
I like the plastic ones best. They seem
rambled
to
a lot.
hold up a little bit better.
Get on
They're
with
not.
it.
You
Here we
just
go.
the end, and you pull the rest of the slack for me. There we go. We can make a nice little wave here. And so, and now, I know a lot of you talk about the parts of a wave, and of course I agree.
Obviously,
that's
we're
important to talk about the
doing
parts of
this
a
with
wave. And so,
very short distance, trying to stay in the camera for this one. But you can stretch these out through the whole length of the classroom. And if you have somewhere to attach one side, that'd be great. If you have a student you trust to hold the other side, that's doable. I always have someone hold it. Even this time, the teacher let go by accident and it sprung back at me. You know, he's not.
I don't know if it's an accident.
Oh, I think it's,
You were giving him a hard time for most of the PD.
well, it's true because he didn't know how to spell his own name. It's okay. Stephen is with a V, not a PH.
Oh.
But these are just a great tool. Oh, here, and I talked about you can do it on a table too.
Yeah.
But we do have a link there. It's okay, Bill. Don't worry about it.
Yeah, that's fine.
Uh,
We showed.
Right,
It's
good.
fine.
But where am I? Oh, did I close it out again?
You closed out of it again.
That's not the first time I've closed out of that. But so that's a great thing. Then we talked about different types of light. And some of these we have videos for, and some of them I have videos we haven't linked to. Infrared light's one of my favorite, by the way. You can use a remote control.
Yeah.
We did UV beads.
Yes.
I was going to wear that and I forgot. We did UV beads and we did prism glasses to talk about the visible light. That's Sarah's favorite thing. She uses a candle and it works great.
Yeah, it's beautiful. Always impressive for the students. I like that a lot when you are using the prism glasses, PRISM. It cracks me up every time the students they're prism glasses. What are prism glasses? It's not prism glasses. But that you get that continuous spectrum, that rainbow that you get. shows up all around your light source, and we can show both a candle and then an incandescent lamp, both, and how that generates that continuous spectrum, but that red is always the farthest from the light source. Violet is always the closest to the light source. And there's no possible way you can move your head to switch them. Like you can't ever get it to where red is closest. And then that links up kind of that understanding to wavelength, that red is a longer wavelength. And so it's always farther away. Violet is a shorter wavelength that's always closer. And so I like that connection a lot.
And we even did the sunlight, the one with using a radiometer.
Yeah.
Not a radiometer.
Infrared thermometer.
Infrared thermometer. And we have students do this with infrared thermometer and go out and
3
take measurements.
degrees.
Okay.
You see Bill's very excited here.
But you know what? The white fabric is only measuring 42 degrees.
Oh, that's
Okay.
closer to what temperature is.
Yeah.
Okay.
You say that every
Wait a
time.
minute. This is measuring 42 degrees
This is measuring 42 degrees Fahrenheit right now.
and this one's 70?
Yeah.
Well, now this one's 93 degrees Fahrenheit. So what's happening is the dark fabric absorbs more energy.
All right, but talking about the energy from the sun, what it does to the earth. But when we talk about the visible light, how do we really know there's different wavelengths?
Yeah.
How do you know that, Sarah?
And what we did, we created a virtual lab that we're excited to share now. And we have the teachers do this. We had some Genesis spectrophotometers, Genesis 20, Spec 20s. They use a color wheel in them. We have to leave them on. A lamp warms up for about 30 minutes. We zero it. Yep. Bill's
You
gonna hold
you
this.
might be able to borrow one of these from the high school.
Mhm.
A couple, one for each group or something would work. That's all you need. Do them in groups. You wouldn't need one for each student or anything, but or unless you have stations.
Mm.
But then you can use one. But they're getting harder and harder to find because they're kind of being replaced by the smaller veneer ones that won't work with what we want.
Right.
But they do a great job teaching this.
So
Mhm.
let's just explain what this is real. So it's all this is it shoots normal white light through, and then there's a wheel in there that then rotates that only allows certain wavelengths through.
Yes.
And so you have a sample in there, and then you basically have the light going through, and then either the wavelengths are absorbed or transmitted, how much goes through it,
Mhm.
and then there's a sensor on the other side. So it's literally like imagine a light bulb and then putting a filter in front of it
Mhm.
so that only certain wavelengths of light go through, and then it goes into a sample, and then you have on the other side a detector that tells you basically how much of that light is coming through. Does that make sense? In kind of a simple way. So that's what these do.
Okay.
All right.
So what we do is we use those to get a feel for how do we know where violet ends or where violet begins maybe, and where it changes from violet to indigo, and where indigo changes into blue and blue changes into green, and so on and so forth. And we have wavelengths that are associated with those colors. But if you look, different sources are going to give you different ranges for the different colors that we see. We know the acronym that we use for visible light, for color, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. But we know that there are wavelengths associated with those, but we want the students to be able to say, to be able to put a wavelength with a color that they see. And so that's kind of, how do we measure visible light? That's the idea behind this. So we have a student handout here. We're going to go ahead and open that. It'll be a view only. You can go ahead and make a copy of that if you want. But the idea is that we were using the spectrophotometers in the lab, and we were asking our participants to begin at a certain wavelength. We began at a very low wavelength. So I think the instructions were 325 nanometers, or as low as your spectrophotometer would go. And then we increased by nanometer until we first saw, let's say, violet, and then keep going until the last point that we saw violet, and then the first point that we saw indigo. And then we kept going through there. Maybe we can't differentiate between violet and indigo. It kind of depends on your spectrophotometer. It depends on, you know, what you're able to observe. Maybe you only see, you know, violet and blue, and that's okay. You don't have to put values for each of these. You just make observations for what it, you know, record data for the observations that you're making. So we were going through, we were using the up or down arrow with our nanometers, and we were getting values for each of the colors that we were observing. All right. This is an introduction video, kind of goes through what we were just talking about. But then once the students had their data listed in the results, so that table is there on the student handout, the idea here is that you would make a copy of this Google Sheet, and that you would share this Google Sheet specifically, the same Google Sheet, with all of your students. So that's the only thing that's a little tricky, is you just got to make a copy of it for your class and share it with your students. And the idea here is they're going to be inputting all of their data beginning with row 24 down. So you could even assign each group a row, or just tell them, you know, just start inputting your data, you know, however you want to do that. But we set this sheet up so that as you're inputting your data, it's automatically going to average the wavelengths that you initially see it and that you finally see it for each of the colors, and generate this really cool graph where we have our students kind of crowdsourcing the wavelengths associated with each of the colors. And we have an example of what that looks like listed here. So we had our participants go through and enter in their data. Not all of them included data, and that was fine. It still works. But then this is this really neat waterfall graph that we have generated from that data that's input. And then we have data that our class observed. Hey, I saw violet going this range, and I saw red at this range. Oh, let's see here. Breadcrumb trail for the for where we are on this website.
Yep, got it.
And thank you for that. And so then I think it gets to a point, some of the discussion that we had is, you know, students like to be right. I go, no, it starts here. This kind of eliminates this. You know, I might observe violet beginning at 375, and another group might observe violet beginning at 386. And that's okay, because ultimately we're looking for that average of all of the data that we have. Now, what if we don't have access to a spectrophotometer? What then? So what we were able to do for that is right here, if you don't have access to a visible spectrometer, we went ahead and we took footage of beginning with, I think we started at 350 nanometers, but it was fine because there was nothing visible. And then we went through, and you'll have to audibly listen. We weren't able, just with the different angles that we were getting, to get that. But it's going to go through, and you're going to be able to see exactly what we saw in the spectrophotometer, and we run through the entire spectrum. And so this is kind of a best case scenario. You know, if you're looking to be able to collect that data, we've hooked you up here on the webpage, and Stephen's kind of quickly fast forwarding through this. You'll hear the beeps. I think after a while, I just started saying every fifth wavelength. And so each beep is giving you the next one.
620.
You said something earlier.
Mm-hmm.
You said what?
Oh, while there's your high school teacher, if you are connected, or you can go talk to them, they may even have one of the older spec 20s or this like that. A lot of schools have them. Some of them work, some of them don't. But once again, if you talk to your high school teachers, they may have a couple that work. The great thing I will tell you, and I taught at a high school that had the middle school and high school combined.
Mm-hmm.
And since I taught middle school and high school, I was able to do stuff with wavelengths in middle school and do some of this where they would know that, so that when they got to the high school, I knew they had that previous knowledge already. So it was faster for them to go. So if there's any way that you can do this, I think I think your high school teacher will be more than happy to let you borrow those, because they know you're going to be giving them that scaffolding before they get to you.
Great thing for waves.
And it is a great thing for waves. And it's a great thing when you start talking about, okay, once again, we're looking at the solar eclipse, and, you know, we have light and stuff being filtered through, and, you know, why do we have, you know, certain days when it's, you know, how can I still get burn on a cloudy day, and all this other things. Okay. So, I mean, understanding that, and they don't have to memorize in my mind, you can tell me different. They don't have to
Yeah.
memorize the wavelengths. It's not like I'm going, okay, ready, quiz, what it's at 520, you know?
What is red?
Yeah,
Well,
but I don't, but that's not the point. But then for them to understand that they are different wavelengths
Mhm,
and that it goes in this order,
mhm.
I think if they can get that at least one time in middle school,
Mhm.
huge for high school. That's my 2 cents.
Kind of going back where we were showing the coil and you were using, two of us were holding the coil and one person's kind of moving it up and down and generating that wave. I think that also kind of relates here. And then Bill was just mentioning about the different energies associated with that. We're just talking about wavelength as we're observing it based on color. But then I think you can get into a whole thing in waves and how much energy they have. And so we see violet, and then if you go past violet, we get into that ultraviolet, and that's more energetic. And then we start worrying about like potentially sunburns and things. But if you're trying to create shorter waves with a coil, you're going to be moving with a lot more energy to try to make those waves shorter. You can feel and you can see the person that's generating those really short waves expending a lot more energy compared to if they're just showing a nice really long wave and they're just kind of gently moving, or a little more gently moving that coil. And so therefore you're getting those long, slower waves, not as much energy. So that's more the red side, and then getting into microwaves and radio waves. So there's just a lot of connections that you could make with wavelength.
Yeah.
Okay.
So now we're back to.
We had already looked at the up in the air, calibrating the thermometer, the moon phase of the board.
Go to, now let's go to the virtual lab.
Okay.
How we talked about, we're going to show them that.
Yes.
The atmospheric one.
All right.
The virtual lab page.
Okay.
Outreach teachers. All right, we'll do a quick walkthrough of the website to how we got there. We went to the main outreach page, and then we went to teachers. Now, under the teachers tab, the 2023 PDs, that gives you the links to the two that we talked about today. And then below that is virtual PD sessions. That is all kinds of things that we've done in the past when we would do conference sessions, things like that. I know if you're new to writing grants, I would encourage you to watch the one that we talk about on how to write a grant and things like that. We have just, if you're going to do GimKit or something like that, and you want information about that, we had someone talk about that. So there's a bunch of just recorded interesting content. The virtual open house, that's for coding. Skip that. On-campus programs, that's what it says, on campus.
Yeah.
And then it comes the good stuff. The lesson plans and resources. This is these first two are the ones that you're really interested in. Let's show science demos real fast.
Okay.
It's out of order a little. That's okay. You know, it'll automatically open a new tab, right?
Yeah. Oh, okay. That one does. Yeah.
Yeah, almost every one of them do.
All right.
All right, so we have over 100 posted. We have probably about that many more that our video editor needs to edit, but he's busy mocking Sarah and Bill right now. But so just demonstrations, science demonstrations.
Mhm.
So here, type under keywords, type in convection. Let's say we wanted to talk about convection. Well, we type that in and we can see all these different things about convection, demos that we have. All these relate one way or another to convection. Now, you'll see some of them say short demo. If it says short demo, it's going to be a minute or less. If it says teacher edition, it's going to explain to a teacher how it would work. If it just says or full demo, then that is more, how would you explain that one?
It's a demo without explaining to the teacher how the demo is done.
But also not in the format of short. It's just like a video.
It's
that you would
a
watch.
longer.
It's a little more involved.
Yeah.
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 The shorts we tried to speed up so they were a minute or less, under a minute.
Yeah. And so there's literally all kinds here of videos that we have. These are just ones on convection. We can get rid of convection and nope, she's typing, so you can't see. I'm sorry. What were you trying to do?
I was just typing in a different word.
Oh, I was just gonna kind of do a quick scroll through
Okay.
and show that there are literally all kinds of things about anything you're wanting to teach.
150.
115 right now?
Yeah.
Okay.
So this was an idea that a teacher threw out to us. They said, "Hey, boy, I wish you guys had demos." And then we took it one step further by making it searchable.
Mhm.
And this can be searched multiple ways. The cool thing with us is let's say you see something in here or you don't see something. If there's something that you're like, man, I wish you guys had a demo on this. If you want to, you can just email
So these demos
K-12
are going to be
science
using a
at
vacuum chamber.
purdue.edu. I'll put that in the chat. If you email that and ask questions or give us an idea, we can probably figure out a way to do it.
If I turn it on,
Hopefully
it pumps air
this
out.
is a very
And then
good
I can
resource.
open the valve here.
We still have more
To let
demos
air
to
back
add
in.
as well. This is what
Now,
we have
with
at this
nothing going
point.
on inside the jar,
Once
that
we're
is
through our
not a
crystal
very
development
impressive.
season, we will get back to adding more demos to the resource.
All right, then the middle school, high school labs and resources. There's the good stuff.
So a collection of virtual labs that we've created. The idea behind these is that students can get kind of if the lab can't be done in person, it can be done. This is the next best thing. Recording of what it might look like doing it in person, but then also with that data piece. So they have some data that can be collected through watching it. We have another link to the science demos there. We just added our visible light, which we already went through and talked about. And you can obviously understand where we're getting data from that, from the view of that getting the nanometers by the color.
Now, you could take these lessons and do them in person if you have the stuff.
Yeah, definitely.
But if you do that, then you have the perfect thing for a makeup lab
Right.
for students that weren't there. But classifying matter.
That was one from
We
last
did that one.
summer.
Oh, I was thinking of the other. What am I thinking of?
We were going to show the
Oh, no, this is it.
Yeah.
Right? This is it where you
This-
talk about.
yeah, pure substance and mixture. And we kind of go through some example ones that we do as a class. The idea here is that if it is a mixture, you'd want to apply the Tyndall effect. And then if it exhibits the Tyndall effect, then we want to filter it. And depending on if there were solids or no solids left on the filter paper, that's going to tell us what type of mixture it would be.
The video that Steve just showed, that's just a green laser. And so when it's shot in there, it just gets scattered everywhere.
Mm-hmm.
If it goes straight through it,
There's no Tyndall effect.
then there's no Tyndall effect.
So.
Can I pause this for a second?
Yeah.
Sure. I just got rid of the thing again.
Marcy, thank you for letting us know you have to leave here in about 10 minutes. So I know some people may want to leave or have to leave or whatever. So I do want to say this. If you came here and you were like, okay, this is great. Thank you for all the stuff. And you would like to have professional growth points. This is very simple at the end. I'll put my email in here. If you will just send me an email with your name and the last four of your social security number. Now you may think, why am I giving Bill my last four of my social? In order for me to do the document, that's what I put on there is, here's the person's name
And you were told that by someone
at the state level,
at our state.
the state of Indiana.
Their state may not require it.
I understand that, but I'm going to stick with it based off of what we're doing because the last four,
But don't, if you send that to him, don't say, hey, here's the last four digits of
Yeah.
my social,
I-
please.
I know it's the last four when you put it in there. So you don't have to say don't even put SSN or anything else. Just put your name, those four numbers, and I'll get a document to you. What's today?
The 27th,
Okay.
Tuesday.
I'll try to get them done by the end of this week.
Mhm.
And that way you all have those. So if you want that, there's my email. Send it to me, not to the K-12. The K-12 science that I gave, K-12 science at Purdue.edu. If you have any general questions for outreach in general, send it there because then we can get it to the right person based off of what you're asking. You can email each of us individually if there's something you really, but I mean, if you're just like, oh, I can't remember who would know about X, just send an email to that K-12 science and then we'll get it to the right person.
Sounds good.
Is that all we need? Yeah. Okay.
Now, the one we said, well, the groundwater contamination simulation is a good one too. If you don't have a, we'll do that, then we'll do the other. But with this one, oh, you gotta go to the student page, don't you? Here, we'll just do the qualitative one. But it's, so if we're like, okay, we want to see, what number is this? 3? What happens if it's contaminated in 3? Well, there's a video
New post migraine.
about, I'm not sure what they're all about. They went fast. And so we can see what happens if it's contaminated in 3. And so it'll make a plume, it'll come down, you'll see the flow. So just talking about groundwater and what wells and stuff be contaminated. So if you're doing an environmental unit or something about water contamination, this would be a good one for them to do. I'll jump out of that. But then oh, I just deleted the whole thing. No, I didn't.
No.
Am I still sharing, Bill?
No, you're not sharing.
I unshared.
Steve, stop sharing.
I stopped sharing. Where's the thing?
The share button.
All right. The atmospheric pollution is where we wanted to show you, because that's where some of the things we said we'd go back to.
Yep.
That's the, oh, wow,
Yeah.
we're in the red.
Our air quality data today, it's not great air quality today. And this is generated from a Purple Air map. Purple Air map, I think if I open this one, you can see a map of real-time data in our area, but then we can zoom out.
Accept the cookies. Quit zooming out. When you zoom out each time, it takes a minute or two for it to catch up. If you're impatient like Sarah, it's going to take forever to catch up if you keep changing it. And if you're in the Midwest, you can expect not to be able to breathe if you're outside.
Right. Yeah.
Wow, that is the worst I have ever seen.
I think
We need to do a screenshot of that.
Yeah.
Well, and you can tell outside. I mean, it looks.
Yeah, it just looks bad.
It just looks bad outside. Andy doesn't look bad. It looks pretty good at your house, Andy. I don't know. Andy just died.
Oh no.
Sorry. Hey, we have a job opening down in anybody looking for a science teaching job, middle school?
So we have that kind of up there for our area where we have here, but then this lesson overview, the idea is we're looking at air pollution. So there's some different activities we can do. Some involve
I'll get the link.
some sensors. Some we have ideas of things you could do without the sensors. We have a slide deck there. Wildfires in some mountains area.
That's why our quality sucks. Right?
Yeah. But then we have kind of listed down, we have a data dive that we can do. Yeah, let's see. The data dive utilizes data from the EPA, and we have a couple of different locations and different years. And we have students go ahead and pull that data from the EPA site and then do that side-by-side comparison, and then select another location and then answer some questions about that. But then part of this, before we do the data dive, we have students go through measuring some particulate matter. One thing it could be, if you don't have a particulate matter counter, you could use that globe activity that we talked about earlier with the contact paper and collecting aerosol data, just large scale particulate matter on your own and using that instead. Like that's one option. We also have wind speed, relative humidity, temperature data that we're collecting. We also utilize collecting carbon dioxide. And so those are all just, this is kind of the air quality lab that we have. We do this with a lot of student groups each spring.
Yeah. But that purple air map is pretty cool.
Yeah. Purple air map, I think if you've never seen it before, that's kind of a neat one to share. It's constantly change. I like that it's that real-time data aspect and that it's something you can always pull up, it's like I said, it's always changing. And then just talking about where that AQI number comes from. So the air quality index. This is the first I've ever seen it in the red for our area.
Purple. I've never
Yeah.
seen purple other than a real small area.
Yeah. Yeah.
So that's still coming from the fires?
Yeah.
Yeah. Yeah, it's all blown this way. Wow, I've never seen air quality this bad ever
Yeah.
on this map.
Give us a minute while we geek out here, while we're looking at this, sorry.
I have screenshots of the different years of this. I'm going to get this during leaf.
Yeah.
That tab
I'll
up
leave it
there.
up.
Yeah.
Yeah.
That'll remind me. All right. So we have just a bunch of different labs. We try to make each one where you can do it yourself in person, and yet we have a virtual side to that lab, so you can do it virtually. If you want to do groundwater, you don't have a groundwater simulator, you could do it all virtually. If you want to do it in person and you have one of those simulators, then you can just take the lesson and do it in person.
Mhm.
We tried to do that with each of the labs we develop these days. Of course, we started that just to help people with COVID to do virtual labs. Then we realized, a lot of people just don't have, of course, you don't want to leave something set up for makeup lab. And so it's convenient. Then if you just don't have the materials,
Mhm.
you have that option too. And so we have quite a few on there. And that's just one of the things we've put together trying to help you. Something that we're putting together now. Hey, I tell you what, hit me with the YouTube channel, will you? Here. Is the YouTube one around here somewhere?
They're all gonna get there faster than you. There we go. I just gave you a link for the YouTube channel.
Our YouTube channel we mentioned earlier, and please do subscribe and share that out. And something we have on all major podcast players. We do have the Superheroes of Science from the Experts.
There's one simple.
All right, Sarah, this episode is so cool.
This is not
It really is. We talked to Paul Smith, who's the director of lab
But it is a good
demonstrations
timing
at
for this.
the
We're about
Department
ready
of
to have
Chemistry
our-
here at Purdue about
Fireworks.
fireworks. Yeah.
So if you ever wondered how
fireworks from a pyrotechnic professional. But we have the science demos. We put them out on here. As a matter of fact, our list is always linked to these. Our kids STEM degree, we're going to talk about here in a minute, especially the expansion of that we're so excited about.
Mhm.
The podcast, if you like podcasts, we're on all major podcast players. The one we just released this week is about looking for conditions on moons within our solar system that would support life.
Mhm.
And some of them we did a few years back. Don't mess with my wrappers.
How many did you eat?
I got carried away. I might eat.
They are mini candy bars.
All right, there's like 15, 20 of them there.
Good, I'm gonna count. You keep going.
Thank you for counting how many pieces of candy I had. But now they are only 20 minutes.
Mhm.
We got in a rut for a while there, and we were interviewing professors and stuff, and like, hey, and they were getting to be like an hour long. It was killing us. But now they're only 20 minutes for sure.
Yeah.
And then we have our Science for Kids playlist. That's the kids STEM degree, Passport Day, Farm Education, Virtual Wonders on the Wabash, and then our different high school, middle school labs. These are all playlists that we have. Then, of course, our shorts that we have all these different shorts, and there are hundreds of them on there. It's the, that's not what I'm looking for. One of the things we're creating in next month after my vacation is when we'll spend a lot of time on that will be our it's STEM careers.
Mhm.
Just like the demo repository, we're making a STEM career repository. Right now we have, how many you think? Do you think we have, I don't think we have 100.
No, probably 20.
Oh, we have more than that.
We have more than
From
20.
AGU alone.
Oh, 50.
Yeah, maybe 50. I'll buy 50. Accept 50 is an answer. But different careers in STEM. And so these are all going to be like up to 3 minutes long. So they're going to be short. It's going to be searchable by keyword. So if you're teaching something about water, this one would come up, be one of the options. And this is someone from Uganda, and she.
I'm Nahabo Mary Nasser from Makerere University. I'm doing a research on the impact of groundwater abstraction.
And so you can listen to that. We have these, and we have like 5 different languages. Now, they're not all in those languages. What we asked people to do was to give us their spiel in English, and if they had another language they were comfortable in, to be able to also give us the explanation in another language. And so we will have a number of different languages, so if you have a student who is Spanish, French, whatever they speak, then they can find some in their native tongue also. And it's a big project. We'll have this released next month, and we'll be adding to it regularly, because now every time we interview something, and we have a lot of people, faculty who are doing large projects, they'll be having their teams create these. So it's something we're very excited about. Now, the kids STEM degree that we talked about, you going with that one next?
Yeah.
Okay. It says here elementary kid, but I just need to work on our website. We do have a middle school one.
No, we just say kids STEM degree.
Huh?
We just need to say kids STEM degree.
I know. I just haven't updated the webpage.
We have our original version here. We have our middle school STEM degree. This is 10 videos. They're about various topics. Created a lot of them created by graduate students here in our departments across campus. And they're short videos. They're 3 to 5 minutes about the topic. And then they'll have a quiz, a Google Forms quiz, that they'll answer a couple of questions based on the video. They answer all the questions right, and they'll get a code. And they collect all 10 codes. And at the bottom, they're able to submit those codes to generate their own certificate. They do have to put the proper code with the title of the video that they watched. So that's really the only piece of information there. They can input their own name and their school and their teacher. It spits out a certificate, a personalized certificate from Purdue University for them. So that's our middle school STEM degree. We're trying to make it not so kid-like for the middle school. And then we're excited because we are expanding these. We've been talking to a variety of faculty members across campus who would like to add STEM certificates to this program. And so we're hoping
There'll be one like on earthquakes.
Yeah.
One just on earthquakes. There'll be, I can't even remember what they all are.
There was one that might,
What's that engineering one?
the one, if it gets funded, it's going to be on concrete.
Yes,
concrete.
about concrete.
All about concrete.
Yeah.
If all these go through by end of the
Next year.
by end of next year, we should have a good number of them, and hopefully it'll be good stuff.
As we get them, we will be announcing them. So again, the benefits to subscribing to the YouTube channel, to following us, our tag for everything is at Purdue SOS, but that's where we typically push our announcements, social media. Yep.
Now, I will say a lot of teachers use some of these others.
Yeah.
They will assign not as a part of a thing, but they will assign it as just a
standalone.
Yeah, standalone. So it's whatever. I see a lot of teachers use these independent of kids STEM degree. They'll assign a particular video.
I don't know if it's blocking that, but anyway.
Oh, yeah.
Okay.
Huh?
Yeah. This is blocking the little text box.
That's all right. Keep
blocking. Yeah.
Doesn't matter.
Okay.
Okay.
All right. Anything else that you want to show or explain?
I just want to go back because I know that a couple of people, and I've been given links as we've been going. I'm going to do this one more time. So this is the main link to our website.
Do we want to share your screen?
No. I'm just giving, that's the main link. That's the link to the main College of Science K-12 outreach website. That's the home. Now, if you can either do one or two things. We joke about this. You can scroll down and there's boxes right there that have K-12 teachers, students, calendar if you really want to know what the heck we're doing. Really, you guys are probably more interested in the first two, the K-12 teachers and students. That's where you want to go to start the link. And then you see the contact us. If you click that button, that's the email that we were talking about earlier that allows you to ask questions to all of us at one time. So if you forget where something is, or you're like, man, you guys talked about something, but I can't find it, that's a great way to contact all of us and find that out. Okay. And then the other one was, I'm going to give it to you one more time. I'm going to give you the YouTube channel. Save it somehow or subscribe, and then you'll have that, because if you don't want to go through our website and you want to go to that channel to just look up individual videos on whatever, you can do that as well.
Follow us on your podcast. Make us one of your favorite podcasts.
All right. So there was a,
Organize website activities by standard.
No, we don't currently have that.
Yeah.
so the question was asked, is there any plan to organize the website activities by standard?
The hard part to do that is there are so many standards and so many classes.
Yeah.
And so that's where, I know we started that for like AP Environmental. I never
Yeah.
got through that one course.
Yeah.
And so there are so many different, and then,
So that's kind of why we've been doing the searchable by a topic or by a title, because
it just pull up the page.
it allows us to be able to do it that way.
Pull up the page. All right, can you see right here? If you're on our outreach page, you have to be on the outreach page. And then here, type in something. I don't know. Waves. Enter. And then everything under us on waves.
Yeah, we made our individual website searchable for stuff in our website. So if that helps find something quicker, now you're still going to get, I mean, waves is, we've done a lot with waves, but I mean, if you were trying to look up something that was
Let's
very
walk this up.
specific.
Earthquake.
There you go. We got two things on earthquakes.
Hmm.
So that allows you to search a little bit easier inside of our website. Hopefully that was helpful. I'm glad you remembered that. That's huge. Woohoo!
Now, what we need to do better, and I apologize that we haven't, is put our keywords in our activity pages. I've not done a great job at that when I've made those web pages. But
Partly we didn't know until that, but